start with a demo?
You want to start? All right, fine. We'll start with our gotta. Just for Juliana.
Good morning and good day, good evening, everybody. We are live from an unnamed outcrop east of Caballito. We have just spotted our first octopus of the dive. Joining me today is Dr. Janet Boyd from the Field Museum in Chicago, and she'll be narrating for us today. And this is a very exciting day because she's the octopus expert for this voyage, and she is very excited to see this little fella.
I tell you, it's got to be a great day when you start with a picture of an octopus like this. I mean, just beautiful as can be. This is an animal of the genus Granulodone. You can tell by the bumps, single row of suckers, which is hard to see because he's going like, I don't want to deal with you this early in the morning. So he's leaving. But the characteristic texture is readily apparent. So we're just like getting sat down and figuring out what to do before we head to marker Q, which we put down not our last dive. Yesterday was at Dorado, but the dive before here. We discovered a new area of low temperature venting. Actually, we discovered the octopods that had known about it for a really long time. Then we discovered the low temperature venting. So we're going back to take a look at them, get some more video, get some temperature, get some water sample, do all those things to make everybody on the boat happy. Gorgeous video on this guy. It's a good job. All right, marker Q, of course, is uphill. It's toward the top. And I'm no geophysicist, but I always figure heat rises, so the top is where you go when you want something hot. It's not toasty hot. What, 3-4 degrees Celsius? Which, if you're an animal living on the bottom of the ocean where it's 1.8 degrees Celsius, is warm. It's amazing these guys can tolerate that change, actually. It's the whole group may have this ability. So tempting to want to stop and look in each of those little nooks and crannies, but we're on a mission. There's a rat tail, I think, that fish just right at center. It's a nice Galathea just poised there under that big, delicate looking sponge. Feathers, nope. Pycnogonid or a sea spider. It's one of the dinner plate sized ones. They're just amazing. Most of them are, fraction of an inch across or 2 centimeters or smaller. They live by sucking the juices out of other animals, which is really pretty cool when you think about being that small. I wonder if they have anesthetic they inject before they hit their prey. It's a lovely sponge. Phew. Don't know if it's still alive, but it's still contributing surface area. Wonder if everybody's inside. We got down looking. No, don't see anybody. There's marker Q is insight. 2 o'clock. Waypoint 1.
They should have drawn, it would have been your fault. Oh, it must have been. Yeah, right.
All right, the dive plan says we're going to look for additional video, or gather additional video of octopods and other beasties.
Sorry. So we're going to be trying to get some additional key probes and squeezer samples and then chunk some more stuff out here. So we may have to reposition some of those experiments that are already there just to get to where the lowest water is.
Okay.
We also kind of arbitrarily picked that spot up there as opposed to this spot down here. So maybe actually let's start where these lower octopus are. So do some T probes here and see how long we can see it.
All right.
All right, we're going to be doing some temperature documentation here. See what's going on. How hot is it? Just coming up here, we don't see the shrimps that really pestered the octopods at Dorado yesterday. But here, there's the little flat Galatheid crabs. I bet they'd chow down on octopus eggs too. These octopods really have a vicious life. I mean, things are coming at them every step of the way. I still don't know what's going on with the stages of the life cycle between hatchling and reproductive maturity.
That's probably the implication is the most slow. So I don't know if like that big dog to your left is going to be a good spot. If that's too far down, I don't know. That should be good.
2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17. Well, I'm counting 18 octopods in this frame. There may be more. I'm assuming that periodic arm I see is a separate individual than the other ones.
Now, once he has the probe, I'll be able to bring us a little closer as well.
Yep.
Right there. I also swing around and look over the top of that board at our time away.
Okay. Yeah, we'll see.
All right.
Once you get the tipper out, I'll do some zooms around this. See where there might be good spots to poke.
Just there about, 9 o'clock, I think you see a little octopus under a rock, under the talus pile. And if you look to the left of center, you see green egg cement, or what looks to me like egg cement. It's like the area of venting at one point, assuming the octopods brewed in fluid flow, had been larger. Maybe it's just, something that fell down out of the, 2,800 meters. A water column ahead of us, above us rather. All right, this is the temperature probe coming out.
Let's steal this from you.
Sure. Do I have to see?
No, no, no. I like you narrating.
It's a little closer than.
You're fine.
Okay.
I'll just hover.
Better hover me than him.
Touch your arm on that stuff. Bring your arm up, pull up a little
Maybe
bit.
around this part.
Okay, Beth.
All right.
You see that bright green right there between what, 5 and 6 o'clock?
Mm-hmm.
That's got to be egg cement.
Yeah. Looks like this has been a populated area.
So what happened to them? Did they all have their young successfully fledged and the parental generation has gone off to the happy place, being among the dearly departed? Or are those crabs still digesting that gushy yolk that we saw
we don't see
yesterday?
any shimmering, so there may be no venting there anymore.
Oh, look how
No
trashed.
shimmering there is.
Yeah.
Yep.
Those eggs right dead center of the screen,
Yep.
not viable. So something's getting them. Oh, check out the polychaetes too, just to the lower right of that. Fuzzy guys. I'm no good on polychaetes, but I'd say they're predators. And of course, the evil-eyed shrimp.
Yeah, there's several of these polychaetes.
Yeah. We may have gotten one of those in a suction sampler. Don't know we have a polychaete expert on board. These are recently taken because you can see the stems of the eggs still there. I think yesterday I was watching the shrimp clean up the last remnants of their octopod egg meal.
So Ben, I think that area around the green cement, right in the center of the screen.
Right here?
Yeah, right in that. We'll just try to get in that area and see what we're at.
Oops.
Alright, well, you might give you a reference time.
Yeah. You done temperature measurement logging before? Jim?
This would be a good site to get temperature measurements. It doesn't look like there can be a lot of mixing from the ambient seawater. That's something in some of these open pits. You just don't know what's going on at the actual origin, where that fluid's coming out of the base.
I might have taken this off of that rock. But we're back.
Is it okay if I zoom in, Ben?
Yes, please. Feel like your sit, pretty good distance to go still.
So we're already starting to see the temperature go up.
Can we put that
It's up,
on?
it shows up
Oh,
there
okay.
and there.
Thank you. I only had 1 cup of coffee this morning. Shoot.
So max is 4.5 so far.
5.
There you go.
Yeah.
That's higher than we got the last time we were here, isn't it?
We got up to 6 at marker Q.
6?
Oh,
Go, go, go,
quite
go,
small
go.
in the mess.
Yeah.
Well, in the mess. You should have been in the air. People freaking out.
All right, the octopods don't like that.
Oh, there's a shrimp.
so we'll call that max temp 6.15. Then you can go ahead and retract.
Not if that octopod has anything to say about it. He can't. He said you give and then you take away.
And if you can just hold for a moment, Ben, I'm gonna look around a little bit more. What do I need to do to get the autofocus to work? Thank you.
That shrimp looks really similar to what we saw yesterday at Dorado with those ridges on the mid-sagittal crest.
Video highlight and call it two-shot octopus shrimp. Okay, doesn't really look like it's more over there. So do we think we could bring a squeezer into that spot that you just probed, Ben? Or will that be too much of a reach and we'd have to reposition?
I think we could do that.
Okay, let's try one of the squeezers, please.
All right, we're going to try and sample some water here, which sounds like a really good idea.
Yeah, so where do you want to put the tank?
First one, fire.
In that porch up
We
too?
can get fire. We haven't done one yet. No. They worked yesterday. We've never tried them yet.
Does it matter which squeezer?
It doesn't matter.
Okay.
You want to just ask? You probably should be able to. You want to porch out, just keep them on.
Say again?
You want to porch out just for that?
Okay. I mean,
It's probably more right there.
They just sitting, relaxing. They're not actively respiring. There's no labored breathing. The shrimps are in check. This seems so much more serene than Dorado, where the shrimps are like, I'm hungry. Of course, maybe they just ate.
I'm here.
Oh, okay.
Take your time. It gets caught on the screw for the caliper tester.
All right, well, while we're arranging to get this water sample, I'm going to hand off dive narration to Beatrice, who has, in addition to extraordinary knowledge, the ability to communicate both in English and in Spanish. Lo siento, my español is really bad. You all have a great day.
Good morning. As Janet introduced me, I'm Beatriz Naranjo. I'm from the University of Costa Rica and from the Pelagos team, a small NGO here in Costa Rica. I'm really happy to be here. I'll be narrating the next hour, and as Janet also explained, I will be switching between English and Spanish. Buenos días, mi nombre es Beatriz Naranjo, soy de la Universidad de Costa Rica, del colectivo Pélagos. Estoy muy feliz de estar acá hoy con ustedes. Voy a estar narrando la siguiente hora. Es una suerte que tenemos un equipo muy grande de personas que hablamos español a bordo. Para aquellos que nos han estado siguiendo, ya saben que cada hora tenemos una persona distinta explicando lo que estamos haciendo. Y para aquellos que no, les comento que estamos ahorita explorando en una zona cerca de 200 kilómetros, aguas afuera de la costa de Guanacaste, al norte de Costa Rica. Y estamos en este momento a unos 3 kilómetros de profundidad en un sitio que exploramos hace unos días donde encontramos señales de flujo de agua caliente, que es una de las señales que andamos buscando y que creemos muy importante para estos pulpos. Hace unos 10 años se visitó esta zona y se encontró esta zona llena de pulpos en otro sitio donde estuvimos ayer, que se llama El Dorado. Y ha sido bastante emocionante poder ver todas estas investigaciones. Tenemos un equipo multidisciplinario a bordo, entre ellos una geofísica que me comentaba que ha estado haciendo hizo modelos por 2 años y medio, y este sitio donde estamos explorando ahorita, que aún no tiene nombre, fue uno de los sitios donde los modelos proponían que podía suceder un evento similar al que se encontró en Dorado. Y gracias a esos modelos y todo ese trabajo de computación, estamos hoy aquí. Hace unos días que estuvimos aquí, quedaron algunas cosas por hacer, algunos experimentos que tenemos que colocar aquí abajo, y esa es la razón por la que decidimos volver. Como ven, hay un grupo de pulpos que están incubando sus huevos. Y lo hacen en zonas específicas donde hay esta ventilación de agua, esta salida de flujo, que sale un poco más caliente que el resto del agua debido a correr en la corteza terrestre, y ese recorrido por una cercanía más al centro de la Tierra, digamos, se empieza a calentar y luego se descarga en otros sitios también rocosos como este que estamos viendo, con unos grados un poco más altos, una temperatura más alta a la que observamos en el resto de la zona. Como ven en pantalla, el agua está alrededor de 2 grados centígrados, pero cuando colocamos las pruebas de temperatura, que fue lo que estábamos haciendo antes, en este sitio obtuvimos alrededor de 6 grados. En Dorado hemos encontrado temperaturas mucho más altas, inclusive de 10 grados. Ahorita lo que estamos haciendo es recolectando muestras de agua para estudiar la química de esa agua. Así que es básicamente una jeringa que está logrando obtener estas muestras. Hoy me acompaña conmigo Miguel Semedo, de Portugal. Miguel ha estado haciendo unos experimentos muy interesantes con metales, estudiando cómo estos pueden estar afectando estas zonas, y es una línea base que nos va a dar mucha información para muchas actividades antropogénicas que lamentablemente se planean en zonas profundas. Es uno de los temas que nos preocupan bastante, ¿verdad? Hay mucha presión por hacer actividades económicas en estas aguas, como la minería, como la pesca. Y bueno, al nivel de Costa Rica, para aquellos que nos escuchan tanto de Costa Rica como de otros países, en este momento pues hay algunas situaciones pasando en el país, incluyendo la pesca de arrastre y otras que son temas de aguas profundas sobre ambientes que realmente no conocemos muy bien, y que parte de estas expediciones lo que intentan es informar todas esas posibles actividades que en algún momento y en tanto, no solo en algún momento, sino también en la actualidad se plantean hacer en el país. Entonces estamos haciendo un trabajo muy importante porque es básicamente fijar una línea base que nos dé todo ese conocimiento para en un futuro poder informar.
Okay, go ahead and stow that. That's fine.
No.
I'll go print one for you. Yeah, we can just mark the number one. Inspired. Or not inspired. And we'll try to grab another one and try it again. I'm gonna go get another dive basket back for you guys.
Basket money, it's not here. No, no.
Okay.
The squeezer didn't fire, so we will try again to collect a sample of the water with this squeezer. We're basically taking water samples to study the chemistry of the water. We are exploring an unnamed outcrop where we went exploring a couple of days ago, and we find signs of venting and also a group of octopus breeding here. Remember that if you have any questions about the work we are doing, we will be happy to answer them as far as we can. Aquí conmigo también está la doctora Beth Orcutt de Estados Unidos. Ella es una de las cojefas científicas de la expedición. Y hemos estado muy agradecidos con ella porque realmente ha puesto mucho esfuerzo en incluir un grupo grande de costarricenses, también de otros latinoamericanos y del Caribe, dando oportunidad a muchas personas que estamos aún en etapas tempranas o relativamente tempranas de nuestras carreras. Como aprecian en la imagen, hay una diferencia bastante grande entre las rocas que están a la izquierda y a la derecha. Las de la derecha se ven más sedimentadas, con sedimento encima, y las de la izquierda no, y esto es precisamente por estas señales que buscamos de agua emergiendo de la corteza, que mantiene las rocas limpias. Y como ven, hay un grupo de gusanos blancos en las rocas de la izquierda, que es donde están los pulpos, y esas también, aunque a veces no vemos el agua como tal emergiendo o mezclándose con el agua más fría de los alrededores, vemos una comunidad de organismos muy diferente. Esto a nosotros nos recuerda a los emisarios de metano, que es otro de los ambientes de profundidad muy importantes que tenemos en nuestro país y en otros lugares del mundo, donde hay muchos organismos que se basan en una base de alimentación quimiosintética. Vemos muchos camarones, gusanos, algunos cangrejos que se asocian a este tipo de ambientes.
of the auto iso there.
Say again?
You got auto iso,
Oh,
but I got it right.
Como aprecian el trabajo que hacen los pilotos de la ROV, es bastante importante. Son bastante diestros en lo que hacen y son capaces de manipular equipo muy meticulosamente bajo el agua. Oops. Vamos a intentar esta nueva muestra de squeezer. Antes de que yo llegara acá estaba la doctora Janet Boyd. Ella es la especialista mundial en pulpos. Y ha sido un honor tenerla a bordo aquí trabajando en nuestro país. Es ella la que ha estado asesorando todo el trabajo que hacemos con pulpos, ya que es uno de los componentes principales que tenemos en la expedición.
No.
Yeah, for those that have been watching the videos the other days, if you're wondering if we have made some progress, yeah, this one fired. So yeah, we have been improving these squeezers, and yesterday we were able to collect some of the samples that were not working on the other days. So this one fired, and we will be able to study this water that we bring. Also, there is people in the chat wondering about the plural and singular of octopus. And what the doctor Janet Boyd was explaining us is that it works same as with fish, right? If you have one species and several individuals of that species, you can still say fish or octopus in this case. But if you have several species and several individuals of different species, you can refer to them as fishes or octopuses. Como ven en la parte de atrás hay unos tubos de PVC. Estos tubos son experimentos para estudiar comunidades microbianas. Tenemos un investigador mexicano que trabaja en California, que es el que ha estado colocando estos experimentos bastante interesantes, exponiendo diferentes materiales en estos ambientes. Y la razón por la que los colocamos aquí es porque queremos hacer un experimento de varios meses, así que ese es un sitio que vamos a visitar nuevamente en diciembre.
stick here.
So, this one, and I think they have
So today we are collecting additional footage of octopus and other fauna that we are seeing. We will also we already did some additional temperature measurements, and as you saw, we were collecting some squeezer samples. We are here at Marker K that we deployed some days ago when we discovered this venting site on this unnamed outcrop. And we will be here for a while deploying new experiments, taking new samples. And after that, we will explore new sites and see if we can find venting around the summit of this feature. Many of the sites that we have been exploring don't have a name yet, so it's part of the work that the Costa Rican team here on board want to do. There are some paperwork needed for that, so we are really happy to be able to name for the first time previously unexplored sites of our country. This has been an amazing opportunity for us to learn more about our own ocean and to learn a lot about the biology, geology, and all the disciplines that our multidisciplinary team brought to this expedition.
Just as free text.
So we are moving the experiments, but this will come back to this venting area after we were here for a while. I'm seeing some questions about the nurseries and if we visit them again. And yes, our first dive was at Dorado Outcrop, and we went there yesterday. But it will probably take some more time for the octopus to use this pottery that we put on the bottom. So yeah, we will come back in December and see if we have any luck with that experiment. But yeah, actually some of the octopus use the PVC tubes. Not these ones, but some bigger ones that we put in Dorado Outcrop during the first dive.
It's attached to something that don't, what you are grabbing is fine. I just realized that was here. So yeah, the lanyard is fine. You just want to grab the horse gate float. It's attached to something else.
Okay, what's gonna happen if I pull it up?
So, this right here, it's fine.
Yeah, it's a better side of venting.
Is it same?
We're just moving the stuff from the other day so that we can get in here. Good morning. And then once we get these out of the way,
So we will stay here for a while, and we want to have some amazing shots of this octopus. So we will be playing with the camera and trying to collect some really good footage about the octopus. Además de, bueno, ahorita estamos moviendo estos experimentos que van a volver al sitio. La razón por la que las estamos moviendo es porque queremos trabajar un poco más en esta zona donde hay salida de agua caliente. Queremos obtener algunas tomas de buena calidad. La otra vez tuvimos que trabajar un poco rápido en este sitio, lo encontramos un poco cerca del final del buceo y no tuvimos mucho tiempo para hacer para cumplir todas las metas que queríamos cumplir en este sitio. Entonces vamos a estar haciendo algunos acercamientos para tener buenas imágenes de toda esta comunidad. No solo de los pulpos, también tenemos muchos camarones, gusanos, algunos otros crustáceos, como algunos cangrejos que vemos por ahí.
Yes. Do you want us to move that top one out of the way because I can let the shots from the top up there?
Why not? Yeah.
Just because it's close to each
Aquí
other.
podemos ver lo que les comentaba, de que cada experimento tiene diferentes materiales adentro para estudiar la colonización microbiana. A bordo, además del equipo científico, también tenemos artistas que nos han ayudado a plasmar todas estas imágenes tan bonitas que hemos visto de mar profundo en sus lienzos y en sus cuadernos. También tenemos personas que saben mucho sobre producción audiovisual y cómo obtener buenos planos para transmitir todo esto que estamos viendo, no solo en términos científicos, sino también en imágenes que se traduzcan en inspiración y en apreciación del público general. Agradecemos a todas las personas que nos han estado siguiendo durante la expedición y que nos han enviado sus mensajes, especialmente a todas las personas de Costa Rica y Latinoamérica, de nuestra región. Hemos comentado ya muchas veces que estas son oportunidades bastante valiosas que no tenemos todos los días y que muchas de las expediciones que se realizan en nuestras aguas o el conocimiento que se genera de esas expediciones pocas veces es compartido con científicos y científicas locales. Y creo que eso es más allá de la ciencia, esa es una de las cosas más valiosas y uno de los logros más grandes de esa expedición, que las personas que la han estado organizando esperan que sea un ejemplo a seguir de cómo deberían hacerse las expediciones en aguas internacionales, tomando siempre en cuenta a las personas locales del país donde estén. Como les comentaba, estos camarones y gusanos y otros organismos que estamos viendo en pantalla son muy similares a comunidades que tenemos en emisarios de metano en el Pacífico Central de Costa Rica, en aguas profundas, por supuesto. Hay algunos lugares en esa zona que llevan el nombre de quepos, llevan el nombre de jacó. Y ya como esos lugares tienen nombres en español, una de las metas que tenemos el equipo costarricense a bordo es nombrar todos estos lugares que aún no tienen nombre. Y por supuesto sentimos mucho privilegio de poder hacer eso, de poder poner nombre a lugares de nuestro país que nunca habían sido visitados.
Did you see those tiny little
Yeah,
crustaceans?
yeah.
Do you know what they are?
Not sure. Probably
Me either.
isopods, maybe.
A weird type of isopod.
Yeah, you think the same?
Yeah, we made the same.
Yeah,
weird
maybe
isopod.
maybe we will have time to start some of them, right? Or, no?
I know somebody who used to work on it. There's another polycule.
Yeah, there are some polychaetes around.
Is it Polynoa? That one looks like it has scales.
Yeah. En pantalla vemos, además del pulpo, por supuesto, vemos muchos gusanos. Justo a la izquierda del pulpo que teníamos en pantalla, estamos viendo un poliqueto, un gusano poliqueto. Y también hay muchos animales, estos que están adheridos, que parecen candelabros. Y de hecho, estos que parecen candelabros, precisamente así es el nombre científico de la familia, Candelauridae, son organismos nidarios que están en el mismo grupo de las medusas y los corales. Y hasta ahora solo los hemos observado en este sitio que estamos en este momento.
Dora Billet up in the succulents.
Where?
There.
What is it?
A Dora Billet,
Doribelli?
Dorability, Opiotropa, Opiotropa.
Whenever you find a plane, whenever you find a plane, it's down,
Can you write it?
Opiotropa, okay. So I have here Dr. Janet Boyd that is teaching me not only about octopus, but also about worms. So that's pretty amazing. As I was saying in Spanish earlier, we had the chance to learn a lot about all the from all the scientists that are on board, and that's a good one of the advantages of having a multidisciplinary team, that you always learn something new every day. And yeah, right now we are a little bit close to the end of the expedition. We have about 5 more dives left. And one of the achievements that we made during this expedition is the connection with different students across the world, not only in the States and Europe, but also here in Costa Rica. Yesterday we had a connection from an activity that we call Ship to Shore, with the help, of course, of the Schmidt Ocean Institute, and we connected with several high school students from scientific high schools. So our goal is that all these students can help us to transfer this message of everything we are seeing and how important is the deep sea. And since, for example, yesterday they were from scientific high schools, we know that they already have an interest in science, of course, and we hope that some of them might be interested in joining us as part of the Costa Rican scientific team that is able to inform all the decisions with strong data from the ocean. So it has been pretty interesting to connect with all these students and trying to ask the lot of questions that they have. As you can see, this species of octopus has 2 rows in their tentacles. Yeah, so as I was saying, these moose octopus have 2 rows of suctions of suckers on their arms, and we have been seeing another genus of octopus that has only one. So it's one of the features that Janet Boyd sees when she's watching this octopus on the screen. That's a hairy friend there. Uno de los logros que hemos tenido en esta expedición es la posibilidad de conectar con diferentes estudiantes a lo largo de todo el país de Costa Rica, no solo aquí en el país, sino también en otros lugares. Una de las ventajas que tenemos es que tenemos básicamente la mitad del equipo científico capaz de hablar español, y eso nos ha permitido conectar con muchísimas audiencias diferentes. El día de ayer estuvimos haciendo unas conexiones que llamamos Ship to Shore, o del barco a la costa, donde conectamos con estudiantes de los colegios científicos de Costa Rica. Es una de las muchas actividades que hemos tenido, y para nosotros han sido sumamente importantes porque nos han permitido la oportunidad de poder transmitir este mensaje de todo el trabajo que estamos haciendo, que ellos conozcan el barco con sus propios ojos, que conozcan a todo el equipo científico, y sobre todo por ser estudiantes con un interés en la ciencia. Esperamos que algunos de ellos se inspiren y se motiven a unirse a un equipo científico que sea capaz de informar todas los retos que enfrentamos en cuanto a mar profundo y en cuanto a nuestro territorio marítimo en general, que compone la gran parte de nuestro país. Como comentaba al inicio, Costa Rica es un país marino y estamos enfrentando muchos retos en cuanto a conservación marina. La pesca es uno de ellos. Por ahí hay otros que tal vez pues, nos parecen un poco más lejanos, como la minería. Pero el punto es que si nuestra sociedad no conoce todos estos ambientes que estamos observando ahorita, es difícil que tengan pues alguna noción de los impactos que las actividades que hacemos aquí puedan tener. Y estamos muy felices de poder conectar con todos esos estudiantes. Aún nos faltan varias conexiones. Mañana vamos a estar conectando con colegios académicos no científicos de áreas rurales del país. Muchas de las personas que estamos aquí a bordo estudiamos en colegios públicos, en colegios rurales, y queremos demostrarles que se puede, que con un poco de apoyo y bastante esfuerzo es posible llegar a ser parte de equipos científicos, compartiendo con equipos de renombre mundial. Entonces queremos inspirar a todas esas estudiantes y estudiantes que están próximos a tomar sus decisiones profesionales. Estamos viendo aquí muchos organismos. Este que tenemos a la derecha, de color amarillo, es un crinoideo, está emparentado con los erizos, las estrellas y los pepinos de mar. Abajo de la pantalla pueden ver agua que se está mezclando con el agua más fría. Tenemos un flujo de agua caliente que parece ser un poco intermitente, que viene y va. Y esas son las señales que estamos buscando. Ahorita vamos a quedarnos en este sitio para cumplir algunas metas que tenemos, algunos objetivos en este marcador Q que pusimos hace unos días. Y después vamos a estar movilizándonos por este sitio que aún no tiene nombre, buscando esa señal precisamente, viendo a ver si hay otros lugares donde los pulpos pueden estar y donde podemos ver este flujo de agua. Así que cuando terminemos aquí vamos a estarnos trasladando hacia la cima. Todas estas imágenes en las que estamos haciendo aumento a los organismos, esperamos que sirvan para inspirar a nuestros artistas y para permitirnos hacer productos audiovisuales que nos ayuden a comunicar todos los mensajes que nos urge comunicar. Así que nos estamos tomando un tiempo para analizar mejor, con más detalle, todas las estructuras de los organismos que estamos observando. Wow. The moment when we found this new vent inside was really, really, really exciting. I was explaining in Spanish that there is a hydrogeologist here and geophysicist that was running models in her computer or computers because she needed more than one for several years, and it was pretty amazing that the data that the model showed was able to predict that this site can be an important site for this venting and of course for the octopus that we are studying. A lo largo del día vamos a tener diferentes científicos y diferentes científicas narrando las inmersiones, explicándoles lo que estamos observando, por supuesto desde su punto de vista, dependiendo de su experiencia previa. Como les comentaba, tenemos a bordo una física, un hidrogeólogo, tenemos varios y varias microbiólogos y por supuesto un equipo muy grande de especialistas en biología en diferentes grupos. Tenemos entre ellos a Alice Cabridi, que es la especialista mundial en octocorales, una de las especialistas mundiales, y también una de sus estudiantes que se está especializando en corales negros, que en este momento no los hemos visto en pantalla. Probablemente los veamos conforme vayamos avanzando, explorando otros sitios, otras áreas de este sitio. Y bueno, una de las características muy interesantes de estos grupos de animales que ellas estudian es que son organismos de crecimiento muy lento, organismos con estructuras muy interesantes y con propiedades químicas muy interesantes que de hecho se estudian en parte para conocer esas propiedades químicas que pueden ser bastante valiosas en los descubrimientos médicos. Hay muchos proyectos que están utilizando organismos como estos, como los octocorales, corales negros y esponjas, que podrían contener curas para muchas enfermedades. Así que ese es como solo un ejemplo de cómo conocer mejor todos estos ambientes y nos pueden ayudar a enfrentar muchos de los retos que tenemos como humanidad y cómo ese conocimiento es necesario para, antes de destruirlos, poder utilizarlos de una manera adecuada que realmente nos beneficie y más bien no nos perjudique. Como ven, es muy interesante ver a los pulpos en áreas en este caso, comparado al dorado de ayer, donde hay montones de pulpos, ya que hay más salidas de agua. Las salidas de agua ocupan un área más grande comparado a este. En este vemos que es como muy puntual. Una vez que terminemos con estas imágenes que estamos recolectando, vamos a poner nuevamente los experimentos en su lugar. Tenemos que dejar acá otros nuevos experimentos. Entre ellos vamos a dejar más experimentos para microbios, como estas trampas de microbios. Vamos a dejar un experimento que sin baterías, sin ningún tipo de motor, es capaz de estar filtrando agua. Es un diseño bastante ingenioso que usa diferencias de salinidad dentro del experimento para activar ese flujo de agua por ósmosis, para los que conocen el nombre. Se ponen como unos frascos con sal que hacen que el agua vaya de donde hay menos sal de donde está más salado a donde no. Y entonces eso permite como este movimiento constante. Vamos a dejar también un experimento de madera para ver qué la puede colonizar y tomar algunas muestras de agua, así como muestras de rocas. De esta forma podemos hacer estudios bastante integrales que nos permiten entender un poco mejor todo lo que pasa aquí abajo, y además de las muestras que trae este vehículo operado remotamente, también hacemos trabajos desde el barco con botellas que se envían desde el barco a diferentes profundidades y se cierran a diferentes profundidades, trayendo muestras de agua que nos permiten conocer muchísimo mejor la química del agua. A bordo tenemos también a Celeste Sánchez, que es especialista en una parte muy importante del estudio de cambio climático en el ambiente, estudiando la acidificación oceánica o el pH del agua y cómo eso afecta a todas las comunidades.
Where we were just sitting, there was
No,
actually a
no,
little
no,
too.
no, they're not. It's polychaetes, but not.
Yeah, there was one.
Meh.
I think we
That's
collected
exciting. Disregard.
We collected some of those in a previous dive, but they were
Yeah, I thought
Yeah.
that's unexciting. Never mind.
Hay muchísimos de estos gusanos escamosos, son poliquetos. Parece que brillaran de color azul, muy bonitos. Nos da la impresión que al pulpo no le gustan. We are laughing because there are many of these polychaetes, like scale worms. Really pretty, beautiful colors. But we think that the octopus don't like to have all these hairy worms close to them. Hey,
So,
Eva,
how's
how
it
are you?
going? How are you?
We fired
Squeezers.
squeezers. The other one didn't work, but I
Okay.
think there's still one. But I don't know where Beth wants to do that.
Let's do that.
And well, we are,
Doing footage.
Doing,
Okay, scratch that off.
evidently. And we already did this
Oh,
as
cool.
well. So probably we'll do some more. And yeah, this
that's
one
it.
hasn't happened.
Okay. Yeah. Okay. Gotcha.
Do you think these candelabras are easy to collect with the...
Well, so we got one.
This one? Yeah,
It was like literally this big. It was my mistake on a rock.
Okay.
And but I think we can try again, but we should definitely just get a big one.
Yeah.
Bigger than this.
Bigger than the samples from
Yeah,
yesterday.
bigger than
Yeah.
this. Yeah, it was on the bottom of a rock that Beth had collected.
Oh, okay. Una vez terminemos estas imágenes, vamos a como les comentaba, poner más experimentos y también a intentar recolectar alguna de la fauna que estamos observando para poder documentarla mejor. Beautiful. Qué lindo. Estas imágenes nos están gustando mucho porque podemos ver el agua caliente y es algo difícil de explicar. Así que estas imágenes nos van a ayudar mucho para poder comunicar a qué nos referimos cuando hablamos de flujos de agua caliente. Uy. Yeah. Nice moment to have the camera pointing there. Cuando estemos movilizándonos a través de este monte, vamos a estar buscando camarones como estos y gusanos como estos que nos pueden indicar que hay, que hay salida de agua caliente, y también estas marcas justo donde está el camarón ahorita, esas son señas de que ahí hubo huevos de pulpo. Ellos usan un cemento para colocarlos, pegarlos a las piedras. Obviamente la roca tiene que estar muy limpia. Esa es una de las razones por las que estos sitios son importantes para ellos. Como les comentaba al inicio, es muy evidente donde hay agua saliendo y cómo la roca en esos sitios está limpia comparado a donde no. Entonces, cuando llegamos a este sitio hace unos días, antes de que descubriéramos este sitio puntual donde estamos, en este momento, en el marcador Q que colocamos, uno de los indicios que empezamos a ver no eran los pulpos como tales, sino el cemento de los huevos. Así que cuando nos movilizamos, tenemos los ojos muy abiertos buscando todos este tipo de señales. Yeah, in the Canterbury, yeah. But I think many of them have that. I don't know.
So maybe not as, maybe like a strong part of it.
Are you ready?
Yeah, whenever you are.
Okay. For me, it has been a pleasure to join you this morning. Hopefully, you will join us the rest of the day and during the rest of the expeditions. So thank you for being here. I will leave you with Dr. Diva Amon, and see you tomorrow. Para mí ha sido un placer acompañarlos y acompañarlos esta mañana. Como les comentaba, vamos a tener diferentes científicos y científicas, muchos hablan español, así que esperamos que nos puedan acompañar el resto del día, que puedan dejar sus preguntas en el chat. Nos vemos mañana. Voy a dejarlos con la doctora Diva Amon de Species. Ella es de Trinidad y Tobago, ha trabajado muchísimo en la zona de Clarion Clipperton, una zona al oeste de donde estamos, donde hay muchos proyectos planteados para hacer minería. Ella ha trabajado mucho en esa zona y ha sido muy interesante tenerla aquí y poder comparar todo lo que ella ha visto con lo que estamos viendo aquí. Entonces los dejo con ella. Muchísimas gracias. Buenos días. Pura vida. Wow.
Good morning. I'm good. How you doing? Well, good morning, everybody. My name is Dr. Diva Amen. I am from Species, an NGO in Trinidad and Tobago, where I'm from, as well as the University of California, Santa Barbara. And I'm being joined on this Science Watch by Dr. Miguel Semedo from the University of Porto in Portugal. And we're going to be with you for the next hour. It's a pretty full house here in the ROV control room. We're just doing a quick ROV shift watch change. And that's done? Okay. And so, are you going to try to do another squeezer since one fit?
So we're gonna hop back out to market here because we were at a different spot. We're gonna do T-probes,
Okay.
squeezer, whatever else.
Right, so we actually haven't done the temperature measurements for the squeezers at the cube.
Yeah, we did it like I said, just below.
Okay.
We're still in that zone of like info.
Got ya. Cool. So we are currently on an unnamed outcrop east of Caballito. And this was an area that no one had been to until just a few days ago when we were here. And on that dive, we discovered, one of the zoarcids. Where's the, okay, well, it's there. I'm going to put that on the list. On that dive, we discovered this beautiful little octopus nursery. This is the third known deep sea octopus nursery in the world. And so, but our dive was cut short, so we didn't get as much time as we would have wanted. So now we are back here to try to characterize the area a lot better, getting a lot of footage, as you've just seen, of the octopus and other animals, getting temperature measurements to see how hot the shimmering water is that the animals are sitting in, taking samples of that water, etc. So we're going to hop back up to marker Q. Do you need to move the marker back?
No, markers.
No, sorry, the experiments. Yeah. Okay.
Just doing his morning stretch.
Yeah. Yoga. So we're not quite sure, the kinds of numbers in this area or the types of surrounding fauna. As we said, we just got a glimpse the other day. So today we really are here trying to essentially spend as much time as we can exploring the octopus nursery itself, trying to understand the extent of it, and then also going, if we have time, going further, deploying a lot of experiments and other things, and then if we have time, moving further afield to see again how big this stretches. So there's a question about how long these octopus might be brooding their eggs. And that's a great question, and we don't actually know the answer. What we do know is that deep sea animals live very slowly. They move slowly, as you can see here. They reproduce slowly. They take a long time to become sexually mature. And so there's one study from a deep sea species, not this one, octopus species, not this one, one off California, that scientists at Monterey Bay Aquarium Research Institute in Bari were able to visit again and again and again and study her. And they found that she actually sat with her eggs, brooding them for nearly 5 years. And it's the longest brooding period of any animal on Earth. And so we suspect that given the traits of animals in the deep sea and given what has been seen in that deep sea octopus species, that these ones may be similar. However, the catch here is that these octopus are brooding their eggs in slightly elevated temperatures. That's why we're seeing them in these cracks. So one of the questions that we're here to answer is, why are they, is this a purposeful decision? Are they using this fluid, whether the temperature or the chemicals within it, to perhaps accelerate the development of their eggs? And that's something that has been also seen in deep sea skates. A few days ago, we also discovered a skate nursery where skates had put lots and lots of eggs in one place on a seamount. And again, they were around areas where there was some fluid flow as far as we could see. And so that there is this idea that they may be using the fluid flow, the slightly warmer temperatures, to help development accelerate. But we really don't know how long these sit with the eggs for. And it's something that we would love to be able to unravel. So someone has asked how many eggs, how many brooding octopus it takes to make a nursery. This is actually something we were discussing a few nights ago. There's no decision yet, but we said at least more than 2 because 2 is a pair, and so 3 or up was where we landed, but not conclusively. And then, did any of the skate eggs have embryos? Yes. So one day we collected one, and that one you could see had hatched. There was it was clearly open, and the embryo was gone. But then the following day, or the following day after that, it's all blurring together. Those we collected 2 eggs, and both of those were viable eggs. And one did actually have a very small embryo developing. So when we get back to shore, one of the scientists on board, Beatrice, who you were just hearing from, she's probably going to do some DNA work and try to understand what species of skate laid those eggs. And so, of course, here we're fixated on these amazing octopus and the fact that they're all brooding their eggs, or perhaps like this one to the left, hanging out. I can't see if that one's a male, but there's lots of other animals around that are in this fluid-rich environment. So we can see at the top there are these solitary hydroids that are from the family Candelabridae. And then we can also see there's lots of tube worms, serpulid tube worms that make these calcareous tubes on the rocks surrounding. And then there's at least two species of shrimp. Here we can only see one species in frame right now, but this is likely Alvinacaris costaricensis, which is a species of shrimp that was actually discovered at methane seeps off Costa Rica. So, and Alvinacaris are a lot of the animals that we're seeing in these areas of low temperature venting are animals that we see elsewhere. At least the groups of animals are animals we see elsewhere at chemosynthetic environments. So at methane seeps, around hydrothermal vents, etc. Things like this Candelabridae, things like that, that particular species of shrimp, these serpulids, and so on. So, of course, please. Do you want to? Nope. So right now we are looking for some really good spots to do some, well, we do have the temperature probe out, but we are looking for some really good spots to try to get that temperature probe into as direct an opening of the venting as possible to try to get the most accurate measure of how hot that water is. The hottest reading we've had so far on the cruise, I think, was 12. Okay. Yesterday we measured 12 degrees Celsius, which was the hottest temperature. That was at a different site, Dorado Outcrop. So we're excited to see what we see here. So yes, these strange positions that you can see the octopus in, where they look like they're sort of inside out, those are their brooding positions. So underneath them are their eggs, which they're keeping safe. And someone's asking whether the octopus that we sampled yesterday, well, we didn't sample it, actually was in a experiment that we recovered from a decade ago. Did it make it back to the surface? Yes, it did. And thanks in part to the very skillful maneuvering of the ROV team on board. So there are some little crab-like creatures as well. Someone's pointed out, thank you. In addition to the shrimp, other crustaceans, and those are galatheid squat lobsters. So probably from the genus Munidopsis. And again, they're a very, they're known from all over the deep sea. They're one of the most common crustaceans you'll see in the deep sea, but they're especially known from chemosynthetic areas. So the maximum temperature we've had at this site so far, as you can see from the probe on screen, is 6.7 degrees Celsius. Wow, I wonder, it looks so convoluted inside, the fact that there are entire octopus in these holes, right? Like, man. Yeah. So they do look like, these squat lobsters do look like yeti crabs, but they are not yeti crabs. Especially here in Costa Rica, you may know that one of the, I think 3 or 4 species of yeti crab that exist, and perhaps the first one globally was discovered here in Costa Rica, called Kiwa pura vida, because of the saying in Costa Rica, pura vida. And it's the very famous one that has very, very hairy arms, and it dances with them in the fluid to farm its bacteria. If you don't know what I'm talking about, definitely Google Kiwa Pura Vida videos. They are great. But that's not what we're seeing here, though they do live, relatively speaking, not too far from here. Wow, that shrimp has like some bright orange stuff going on in its head. And there's also some pretty big polychaetes in the cracks as well. Beth and I were just talking about the fact that this structure, the seafloor, looks so sort of convoluted. Like Beth described it as Swiss cheese, if you will. Looks like there's lots of crevices and holes and so on for animals to live in, which you can see by these. You get a peek of an entire octopus in a hole, for instance. But you can also see just behind that octopus's arm, there's these quite big polychaetes. I think these are amphinomids because of the huge numbers of bristles that they have.
Max I saw was about 4 in the bell, 6.
Lots of little polychaetes. With her winter shrimp dinner.
Okay, 5.1, Miguel? What's up? 5.7. Oh, 5.27.
At some point, we hit a 7 though today.
Okay, so then I think what we want to do is find a historical temperature probe. We're going to try to do some tweezers.
So now, because we've gotten a good read on the temperatures here, we are going to try to take some squeezer samples. Squeezers are basically kind of like syringes that allow us to take very targeted samples of the fluid emanating from the seafloor. So you may know that we have Niskin bottles as well on the ROV, but those are attached to the ROV and are so therefore like 2 meters off the seafloor, a little bit more. Whereas these squeezers are able to get like right into the cracks and get as direct a sample as possible.
Do you have a favorite?
So forward port didn't fire. Forward starboard already done. So either of those back to will be fine.
The forward starboard one, that's the manual.
No, they're all trigger. Whatever you know, I'm just go.
We do the handoff.
Yeah, we're handing it off to the.
So these serpulids that we can see coating the rocks right in the fluid flow, they're turning out to be quite a good proxy to look for fluid flow actually. But these are tiny polychaete worms that build these calcareous white tubes attached to the rocks. And we've seen them, scientists have seen them at lots of other chemosynthetic environments. So for instance, in Trinidad and Tobago, where I'm from, we have very huge methane seeps. And there are serpulid worms, I'm not sure if the same species, but serpulid worms that form huge beds, like very thick beds that almost form like massive bouldery rocks, if you will, at these sites. And it's thought that they could be chemosynthetic. So interesting to see them here, at least the same family here.
Shrimps will stay there. Thank you, Trevor.
So yesterday we collected a few shrimp species from Dorado. There were two species there. One likely Alvinacaris costaricensis, which is the same ones I think we can see just above the ROV manipulator, where you can see three sticking out. But then there was another one that we think is a Libaeus genus shrimp, and it had in its head, which is where they do this, they basically keep their eggs in their just behind their eyes, within their carapace. And those were bright green eggs. And we've seen that in other Libaeus species, but we were able to sample that last night. But yay, squeezer sample. But this one to the right, there's a shrimp to the right that has bright orange. So not sure what that is. Doesn't look like eggs, but maybe we can get a closer look a little later on.
Come back up, and what I'll do is I'll porch out and give you kind of in between the biobox and the nursery. I'll just come a little bit more because it'll hit until we get to right about there. Okay, that's your turn. Just return this one. Roger that.
The Joel speed back. Okay.
Okay, so I'm just think through what I do here.
Do you want to see them?
No, I'm just trying to imagine the order of operations in my head. I think what I would like to do is take this in, then pick up the rock, then put down the concrete.
So because this is a site where we know there's fluid flow emanating, we're going to do a bunch of different things here. So you can see we've already taken some temperature measurements. We've taken a fluid sample using our squeezer. Now we are going to take another fluid sample, but this time from one of the bottles attached to the ROV. So close by, but not too close, which is what you can see these numbers are. Then we're going to collect a rock sample for microbial and geological purposes. And then we're going to, I think, try to deploy some experiments because we are coming back in December to these sites. And so we're going to leave several experiments on the seafloor for about 6 months.
Five?
And 4.
And then we'll pick up a rock and put it in the biobox three, since they're stuck in biobox one. How we do this without flagging out a
So we don't tend to lift up rocks and look under them. That would only be if there were something that we could perhaps see under there of interest. And I think there's 2 reasons for doing that. One is that, you know, sometimes by lifting up a rock, you're disturbing the environment there. So we prefer, or we try to be as uninvasive as possible. And then secondly, we often have so many other things to do that we just don't have time to be that inquisitive. And in terms of what animals, biological samples we take, there's a few different things that guide that. So first, that might be, again, it depends on the questions, the scientific questions we're asking. But for instance, here, the octopus are one of the main, have a series of questions around them that we're trying to answer. So we have been targeting some octopus. Otherwise, we're also trying to characterize this area because no one has been here before. So that means that we try to take, and again, we sample as sparingly as possible, but we will take the entire organism or piece of an organism, depending on the size, of species that perhaps might be the most common around here, so that we can begin to understand what species that is, which you can often only do by having a specimen in hand. And then we also, on board, we have, for instance, like different taxonomic experts. We have a coral expert, we have a black coral expert, we have someone who's interested in holothurians. So we have been specifically targeting those species as well. But also it's just, for instance, if something may look interesting or new, there is a large degree of, there's some strategy involved, but also some degree of opportunism. And it's trying to balance those 2 things.
before we do that, let me look and see if there's one on the other side. And then we'll-
So we're just looking for a good rock to take.
Oh, that's what I was putting it, right? Yeah, looks good.
Before we do, can I get some zooms? Or near it?
Yeah.
Okay. Miguel, highlight please. Got it? Okay, great.
Wait.
Yeah.
Yep, you're good.
Nope.
Oh, that's what it was.
So there's a question about how the discovery of the second octopus nursery will affect recommendations made to Costa Rica for policy and protection. We really have just begun scratching the surface on what is in this area. And so there's a lot more still to understand. However, I think the most important part of that question is that we do have many Costa Rican scientists on board who would be much better placed to answer that question. However, I don't think there's going to be given we're coming back in December, I suspect there will be some time to allow a little bit better understanding of this place before putting some concrete recommendations on paper.
Ready for the pollution?
Yeah, with micro shots.
So we have come across 2 species of octopus so far. These ones that we're looking at are called moose octopus is the genus. We are not yet sure of the species, whether it is a new species or perhaps the same as the species that's seen off California, also brooding in high numbers. And then we've also seen a second octopus species that has not been brooding in the fluid, so further from the fluid on various sites. And that is a Granelodone. And that Granelodone species is most certainly new. And so we were able to collect both. So Dr. Janet Voigt, the octopus expert on board, is going to be working with local scientists to identify those animals and describe them if new.
What I will do is I'll do the portrait of the captain.
All right, create.
Yeah, I did have more. What I can do is,
That's it.
I'm going to torch back in a little bit. Try that.
Oh, copying fluid.
Yeah, that would be good.
So this is goes so far.
Keep an eye over there. Good so far.
Blocking the view.
I can see it down here.
Almost there.
I can see it a little bit, but it's fine.
Okay.
Yeah.
Shoot for 2.
All right, 3D. Okay, that's gonna require us to position the okay, we want to try to put the milk crate out, and so look at the sit can, The pink roller skate is attached to a metal T-handle that's got the business end of the stuff, with a bunch of cabling inside the basket. The bridle is that black loop that's rubber banded in the front. So pick up with the bridle first, set it down, pick up the roller skate wheel, and then try to put that intake in where the shrimp hole was, shrimp hole is. So trying to think about where is it is, put enough thinking on the stretcher. But we've got about 10 or so feet of
Cable.
So we could potentially put it right in front of us, underneath that male octopus, and then stretch it over. Or
And so you want to put that in the 7-degree spot,
Yeah.
which is right where the ribs are?
just to the right,
Where we did
where the
this bridge.
shrimp is.
Oh, right, okay.
So we could also set it over there, or we could set it up.
Don't create like.
Sure. We could also move stuff around. So all of these things with yellow lanyards up to the right actually need to go back to where the temperature probe is.
So you got 10 feet on that guy?
Yeah, so we could also move all those back and then put the aqua sample up there. That makes sense. This is what's those down there.
One thing, Scott, I think we put an elastic on the peak roller skate thing. You may want to, while we strap to the position, you may want to like talk in loose, just so that when we're, lifting them off the ball, what I mean?
Sure.
I'm not sure.
There's 10 pounds of weight in there.
Okay,
So,
that should be
yeah.
fine. Okay, we'll time it up.
So now the question is, if the milk crate is gonna be put onto the right, we should get all that stuff out of it first.
Yeah, I think so. Yeah, we should reposition
Yeah.
this experiment first. And then put the roll rate where those things are.
Okay.
So we're just going to do some little reorganizing here. These experiments you can see on screen right now are microbe traps. And we are going to come back to collect them in December, but we're just going to put them, but we had moved them out of the flow, so to get some good imagery. But now we're going to move them back into the flow, and then we're going to deploy, I think, an Osmo sampler, so a sampler for longer term fluid samples that again we'll put that in the space that these are in now, and we're going to leave that again until December when we come back.
Yeah, we did it last time.
Okay, so,
That block or the purple one, and put the milk crate right there.
Yeah, we put the marker
The
on.
milk crate was right there. Or yeah, the other thing, does it have to sit as upright as possible?
Yes.
but I don't wanna disturb the heat from.
Ideally, we don't put it on top of the two phones. So before, we can pull up an image of how they were before, but they were kind of just in these areas. Um,
So sure, I disturbed the heat probe
That's perfect.
forbidden.
Pushing it in further is fine.
Oh.
Pulling it out is provoke.
So you'll put that up at Christmas?
Yeah.
How long does that battery last?
Those T-loggers can go for years. I think they're on set. Yeah, and Andy's had it for a long time. We just sent it back to the factory, had it recalibrated. That is,
What's the phone?
I have to ask
Huh? What was the question?
You think that's enough?
If the samples every like a minute, 216.
Which seems expensive.
More is better, I guess. That's why we have computers.
So I wouldn't get any closer to the shrimp, just because that's where we're gonna have to put them out for intake.
Okay. What about down here?
No.
So you think I should break these remains first?
Just, I would grab the pink guy and just lift up one just so that.
You know, I'm gonna be able to.
Oh, all of those? Okay, sorry. Yes.
So while we're just deploying these experiments, I think this is our fifth to last dive for this expedition. We are hoping to dive every day until we head back to port. And so we are, yes, it's so funny. It feels like when you first get out here, you feel like you have forever. And then before you know it, it's nearly over. And so I suspect that each of these next dives will be at a different location in this area. So what we can see right now is there is one temperature probe, which is the T handle, just behind some of the microbial experiments. The microbial experiments do have replicates, but there are also different substrate types for colonization in each of those different microbial experiments, or traps, if we will. And then the Osmo sampler that we're going to put down, we're only putting one down, but it will continuously sample essentially until we collect it. Loving the pink tape.
Yeah, that was a little Easter egg for us.
I like it.
I found it in the bag. I was like,
I
oh,
like
they didn't
it.
bring me pink tape. It's already taped. Yeah. You can call this pink Osmo sampler. rubber bands.
So that we will be looking at them send.
Yep, exactly.
There was a sea star that was interesting
So I can't tell.
but I'll wait for it to reply.
Oh, there we go.
We don't have any sea stars yet.
How are you responding to my text?
I have an idea.
Yes.
You see my problem? The problem? You see that? Okay. What if you grab the edge and just hold it with this arm?
Yeah.
Reach over with this arm, pluck it out, and then you don't have to necessarily plant it with that one, but just bring it with hands. The answer is yes.
It's a safe place to hold.
Grab that back edge, right? The corner there.
There's an interesting sea star. How would you feel about a sea star?
Yes, we can collect one sea star.
They're like,
Because I haven't seen an octopus here.
yeah, there's been the same sea pen we collected, but
They
like
say
one.
crabs, but you really collected crabs, no?
So,
We did not collect any of these Munidopsis.
Maybe the crabs,
One.
star?
Got it. Yeah.
Okay, good.
Let's just let, I mean, you can tell Beth or I can tell Beth. Doesn't matter, but
Oh, yeah. Yeah, you can see it right there. You can see that.
I can't see the sea star was like, and it was pretty big. So once we finish setting up this Osmo sampler to take fluid samples for the next 6 months, we're then going to do a few little biology collections, probably one of the squat lobsters that you're seeing here, as well as a sea star that is around here somewhere. And I've been joined by Dr. Odalisca Brady, who's from the University of Costa Rica Zoology Museum and is the coral expert on board. She's a little sad because we don't have any coral in this particular spot, but
like crab.
Yeah, you don't even have to
this
grab. I
is
would
one of the squat lobsters.
press down through John Maggie. Like that, press into it. That would be perfect. That's perfect.
I would say there's a 40% chance that as you pull the big one out, it's gonna look more than 40%, probably 60%. 75%.
I know
Maybe I
Bia
should
also
grab
really
it.
wanted the little
So-
zoar, the little white eel pout fish, but I don't
I'm
see
just
them
saying,
here.
From prior experience,
Yeah.
they're gonna start pulling that out.
Yeah, look at that.
Turn it off.
There's one
No,
star.
that's not the star I was
But
talking
you show
about.
one that bigger.
It was like chunky. It was like
So
not
I
a
think it's a
Brazingid.
settle there, no?
It's down here.
Can we grab
Yeah, let's see.
like there? Yes.
But let's get the squat lobster first,
Yeah.
since those are like
Yes,
right
yes,
there.
So from, I have what you said. From here down,
Yeah. Oh, that's the
There's
cable.
tubing on the inside.
Okay.
so it's fine to be like right here.
Yep.
But back on this side, it's not great. You could also go here.
Yeah.
But you would want to be on the other side of the table.
He's got it.
I think maybe right here then.
Yeah, you just grab the even if you grab the this way. Yeah, just grab it.
Yeah. And if you want, you could even grab that corner and like turn it 90 degrees clockwise, so that that's the far corner. Yeah, exactly. That way you can like do with it on that way. Where
You good?
Okay, maybe the check.
comments to do this, so it won't happen right away. Just
Okay, so just going to, I might have to do the, I'll watch here.
Yep, okay.
This is a two-hand maneuver, as you can see.
Everything good so far?
Yep, looking good.
and feel free to position it like it's in your
Yeah. Kind of looking for an opportunistic place to put it down so I can grab the team. Then it just kind of pointed right where it's supposed to go, so. Don't do that thing.
With the vibe box.
rocks.
Are you able to grab it with the starboard now, or is that starboard box pretty
Yeah, I mean, it doesn't seem like we need to pull out our cable.
yeah, it just kind of needs to sit in there.
Try that.
They're like
Yes, yes.
big and hairy.
Yeah, because we don't have them.
Yeah. Definitely the orange ones look interesting.
Okay, box. Stay where you are.
Before, like, we leave the area entirely, if we could just, like, these tubes are so weird. If we could just get a couple zooms on them as we fly away. Because they're, like, dotted elsewhere, and there's some pretty big ones that aren't, like, cemented on.
No yawning here.
Especially as you're coming on. Want to see where we are?
Yep.
So we are at marker Q. We've done the footage of Octopus on the Ventona. We've taken temperature measurements. We've collected squeezers. Both. We've now done 3. 2 at just below marker Q, and then 1 didn't work, and then 1 at marker Q. We just moved back the micro traps. We've moved out of the place. We've deployed the Osmo sampler. We've deployed a temperature probe. We've deployed the micro traps. So I think, did we put out the wood exposure?
Not yet.
Not yet, okay. So there's a few things left to do here, but before we go anywhere, Beth is gonna, we're gonna get a few species for Oda. And so that's gonna be one of the muted lobsters, spot lobster, one of the gallophiids, spot lobsters. There's some orange hairy dudes that we want to get. They're like orangey.
Do this?
No, they're not the ones that do this. and then I can't seem to see them anymore, but there was like a big chunky sea star. Not a skinny armed one, like a chunky one who we've seen around.
Okay.
So but Oda's here to advise.
Okay.
And
Thank you.
and then I think we have a few more things to do here. And then
What's left to be done? Deploy the wood experiment, rock sample.
oh no, we did rock sample. Yeah.
Pass that out? Okay.
So it's just deploy wood. We're gonna do this.
Yep.
I don't know if we're gonna do this. Are we collecting an octopus there?
We'll see that movie where they have the hot dog
But you'll
heads.
have fun with that. And then there's also a white zawarcid fish. It's like a skinny eel-like fish. So it's small. It's in the rock somewhere. We've seen one, but then it's like disappeared. But Bia really wants one.
So they said,
Yeah.
okay.
But you might not see one. Yeah. So I'm going to say goodbye for today and leave you in the very capable hands of Dr. Rachel Lauer from the University of Calgary. And she is going to be, oh no, you're done. Yeah, okay. And Miguel is also finished as well. So we're going to be handing over to Dr. Wendelin Matsumoto. But Rachel can introduce herself. Thanks, guys. Thanks, pilots. For being here for a while. I'll stay with you. We'll get home. Don't worry. Yeah, I feel like Alice. On top.
I mean,
Yeah,
you could
that
have
big
a
orange
box,
too.
grab the skateboard here with
Oh, we want him. I mean, he's not this guy. I want to see that. He does look here,
Yeah.
but we don't think he's
But
this.
if you
He's
came
not that
across,
guy.
Okay.
grab.
Yay.
Move it back.
While the scientists are doing their handover, for anyone who might have just tuned in, we're 2.8 kilometers below the surface of the Pacific Ocean off Costa Rica. This is returning to the site that we were at, excuse me, an unnamed outcrop that we were at a couple dives ago, where we very excitedly found more venting and more brooding octopus. And as you can see, we're now deploying some experiments in this area and just working on getting an Osmo sampler deployed right now.
Good morning, everybody. This is Rachel Lauer from the University of Calgary. I will be with you for the next hour. And as was just mentioned, we are back to the site of discovery several days ago. We located, I'm not sure how many in particular, but brooding octopus that appear to be the same species that was located at Dorado. And we are currently in the process of deploying what is called an Osmo sampler. And the objective here is to ensure that the nozzle is deployed in the rock where the warm fluid is coming out. And those samplers are incredible because they require no mechanics, no battery. They are purely driven by an osmotic pressure gradient between DI water and saline water. that essentially pulls a very slowly into a very small inside diameter tubing that is coiled up and allows us to provide a sample for 4 years of continuous measurements. So we recovered one of those from 10 years ago, yesterday, on Dorado, and spent part of the evening cutting that tubing into samples and putting those fluids into vials that represent a time series of fluid chemistry emanating from Dorado.
It's actually not being safe, it's protecting us all from the inside. So even if debris goes in, unlikely to fall because there is no tubing on the inside.
So a lot of discussion happening to make sure that the end of this Osmo sampler is placed directly into that venting fluid. We want to be able to capture the chemistry of that fluid that is coming out. We know the chemistry of the water going in. We have sampled bottom water directly to understand the specific chemistry of that fluid. And what this fluid will allow us to do is get a look at the chemistry emanating from this outcrop through time, and also any differences from the chemistry in the water going in, that bottom seawater. Those differences are likely the result of microbial processes happening within the ocean crust that are either using some of those elements or putting some chemicals into the fluid, and we can actually start to investigate not just those chemical changes and how those microbes are surviving, but also some of those microbes can be swept up within that fluid and sampled directly. All right, so it looks like we're happy with the placement of the Osmo sampler.
So we want to move those final two experiments or guests back in place.
So now that we've gotten that tube directly in the emanating water, in that vent fluid, so we can sample the chemistry, we're going to move the experiments back into the location where they were previously. And those experiments are using different substrates to analyze what microbial communities are using which substrates. And those will be deployed now and recovered in December when we come back here.
Is that the one walked up?
Okay, so a little background on how or what tools are actually used to try and locate one of these sites of fluid discharge and venting at the seafloor. The day before we dove on this particular site, we did a transect near the top of the seamount, outcrop. It is not over 1,000 meters, so technically it's an outcrop. And did a short profile of heat flow and looked around for potential sites of fluid discharge. The heat flow values were elevated, about 10 times higher than background in this particular region of the seafloor, indicating that it's likely a discharge site. And based on where we found fluid discharge on Dorado, which was not near the top of the outcrop, but around the base and near the top, along cracks and fissures within those rapidly cooling lavas that crack as they form. Here we're finding a lot of that fluid venting in similar places within the pillow lavas, as well as these holes that are likely formed as a result of rapid cooling when extruding lava hits very cold seawater. And some of those pockets are formed that we see, in particular right here in front of us. This is more of a fracture that is covered up with some of those pillow lavas.
So we can see which microbes
Yeah, and Beth is highlighting some of the importance of these experiments, which are designed to understand what microbes will colonate which substrates. So there's different substrates in each of these little vessels, and they're deployed now and will be recovered in December. And we will look at, well, the royal Gus will look at what microbes in particular select what substrates to sort of understand their microbial habitats. Which one? Oh, the star. Okay. Did you tell Beth?
Yes.
Okay. Okay.
So before we move, if we can come out wide on the shot, I just want to get.
Okay, it looks like we're potentially going to collect a biological sample.
Wendy, can you take a highlight, please? Of just marker Q after deployments?
So we're taking a shot now just to have a representation, wide angle representation of where everything is, where it was left at marker Q. We have the community experiments, and substrate experiments, we have an Osmo sampler, and we've also deployed a high precision thermistor that is inside one of those vents. And that will be recording a time series of how temperature varies through all of the tidal cycles. And what we've seen, at least at other outcrops, i.e. Dorado, is that in some cases vents turn on and off. And they are not continuous in terms of their fluxes, and which we're actually measuring through their temperatures. Other researchers have used the tidal signature and some fancy processing to understand important hydraulic parameters like permeability. And we know in this particular region, the permeability is very high. Okay, so we can see that the arm is heading for that star. And we are going to sample, I believe. Maybe not. Yeah, there's been some interest in sampling some of these crustaceans as well, the squat lobster. It's not clear if they're going to use the arm or the slurp to capture this guy.
So these ones do swim.
Okay, apparently this could be a swimmer, so there's a bit of debate about which of the techniques to use to collect him. But there is some limitation in terms of the arm's reach based on where we're seated at the seafloor. This little orange guy just to the left of the experiments that were just placed at the seafloor is a squat lobster. We going for the lobster? Okay. All right, so it looks like we're going to collect a few samples here. Hopefully we will be sampling both the sea star and the squad lobster. And as Diva said, the lobster can swim, so it may be a bit of a challenge figuring out how we're going to get him into the bio box.
It's a relative term.
I like that it looks like he's running. It looks to me in profile like the sea star is making a sprint for it, but it's frozen. He's frozen. It's not going to make it.
Like arms thrown up.
Yeah, exactly. Like he just won a race.
Yeah.
It's hard not to anthropomorphize the animals. Yes.
Doing a ballet leap.
Zooms with lasers on and off.
There are some like the other orange scallops from below, if that's helpful.
Oh, yeah, there's one right there. That might be easy.
Which down here?
Very
Type
specific.
Well, no, I mean,
No?
we just we're gonna go for the most are that guy. That's we're just gonna go the as orange as possible.
Highlight photo, please, Wendy. Yeah.
It's a beautiful star.
And then can you use your map just a little bit so we can see the lasers? Yeah.
Okay, we're going to use the lasers to measure diameter of the entire animal.
Okay, another highlight, please, Wendy.
Are these the cement? Or
These what?
these aren't all.
All the green is cement. Yeah.
It is. Okay, so all of these green spots that are surrounding the region where these octopus are brooding are cement from previous attachments of eggs. So you can see how much utilization of this has happened in the past based on where you see that green cement.
Rachel, can I see the
Yep.
diagram sheet?
Oh. Where is the diagram sheet?
Perfect.
Oh, sorry.
Perfect. We can hold it up to the camera before we drop it into the. Yeah, they are. So. Nice.
All right, so we like to get a glamour shot before we put samples into the bio box.
It's like, no!
Okay. Nice job, pilot.
Excellent. And that's our first star then.
Yeah, first they
I-
start.
Okay, this is apparently the first sea star sampled on this expedition.
No, we only got over.
Yeah.
are some swallows that are orangey in the middle that could potentially be other alternatives. So there's like they're kind of orangey colored.
Like, was that these ones here, Dina?
Yeah, so down here, down there. There's one just down below this one.
Oh, yeah.
They swim in directions against the rock, that one.
So what if I just went down and grabbed them?
It's probably gonna go. So, I mean, you can try, but it's probably gonna go.
Okay, I think a slurp would be better. We'll try one. We'll try another.
Are we on to the hydro?
Those are
Families, Canada.
someone grabbed an antenna earlier off the shrimp, so I was curious what
Yeah,
those were.
Canada for day. We did happen to get one on a rock that collected it was this big.
That's cool.
They could be the same ones that they get at like.
So as compared to that sea star, the concern here is that the squatties can actually swim away a bit. And for that reason, it looks like the pilots are going to elect to use the suction sampler, or you'll hear it called the slurp sampler. But this does suck water up, not dissimilar to like a vacuum cleaner. And we have a kind of like a little revolver cylinder on the side that has several collection tubes, and this will collect into the most active one.
Is it that one?
Oh, I see.
I'm just trying to figure out if it's
It would have been like, so this is I don't think we did, because we had very little time on that.
Yeah.
They're out there a little ways.
Okay. So this guy over
Yeah,
here.
before we slurp, we want to get some zooms.
Okay. I'm just gonna do a quick white balance. Yeah.
Could you be on the one that's got the red on it, actually? Curious to see. Found a
All right.
that says sometimes having red on the palette helps.
Doing a quick color balance.
So,
Yeah, so if we could get zooms.
So a couple questions about the green cement that we're noticing all over the site. And there is our next target sitting on some of that cement. The cement is the attachment for the eggs that had been previously laid at this site. It's not clear whether brooding octopus reuse the same sites, migrate or move around a little bit, but we do know that fluid venting is not constant through time. So we may have some spots that are venting more vigorously. And
yeah, roger that, Pete. What I'll do is I'll put your waypoint just somewhere.
The pilots are speaking with the bridge about some ship maneuvers right now.
Great, thanks, Pete.
Okay, let's also, sorry.
what's that?
Let's try that one first. And then we'll do more zooms. What slurp chamber are we in? 2?
All right, so Apparently, this guy is going to be a little elusive, apparently. And given that he can swim away from the manipulator, it makes more sense to use the slurp for the sample. So we're positioning ourselves for that and also trying to anticipate his escape path.
So are you giving him a point to rotate about?
Yeah, but if he rotates now, we'll be up right on the stern.
Yeah.
If I move away from the stern, like if I put it up here, and then he rotates, we'll just be just back off the stern. The launch point is right here. You know what I mean?
So just to, again, give a little background on how we ended up here on this particular outcrop. Way back in the 1990s and 2000s, there was an effort to geophysically image this part of the crust that will eventually be subducting underneath Costa Rica, under the Nicoya Peninsula. There were lots of seismic lines that were conducted crossing these 11 outcrops. I think only 10 were identified back then. And those seismic images allow us to understand where the outcrops are, how thick the sediment is, some of the subsurface crust morphology, what it looks like in terms of topography under those sediments. And we're about to suction this guy. Looks like he's holding on. All right. Looks like that guy retreated a bit. May have escaped being sampled. There's another. I have another potential sample. Wow. This is very cool. Okay, so shifting to sampling this guy.
You might get another hydroid.
I'm just going to talk about geophysics while this happens. Oh, okay. He had nowhere to go, so.
I think I heard him go, "Wee!"
I think I heard him scream. Yep.
I'm the chosen one.
Yeah.
Yay!
Oh, God. Are we attempting for another one, or?
There's one right next to it.
Yeah.
The pinky one.
The right there. He might go into the crack. All right, so going back to the 90s, lots of geophysical ship-based imaging where you're essentially using sound and its travel time through the water column to create, through lots of processing, an image of what's going on below the crust and below the sediment. Following that, in 2001 and 2002, there were two ship-based heat flow mapping campaigns where a much larger heat flow probe than the one we use here was using a crane or an A-frame put over the side of the ship. And in what we call a pogo mode, you would do transects along those seismic lines. And what those heat flow measurements did was reveal that some of these outcrops are recharging, signified by a decrease in heat flow as you approach the outcrop on those transects. And some of those outcrops were discharging, indicated by an increase in heat flow as you approach the outcrop on the transects. We generally use 2D transects, so to think about this, so lines that are crossing perpendicular to one another. And hundreds of measurements were collected in 2001 and 2002 prior to any of us actually visiting these outcrops via submersible. And in 2013 and 14, following lots of funding and anticipation, we were able to dive on Dorado, specifically knowing that this was likely a place of massive fluid discharge. That is because of these measurements conducted in this area, 70% of the heat coming out of the Earth as a result of its cooling was missing. And hydrothermal circulation is the only physical process that can remove that much heat. This guy is really digging in. Wow. Yeah. And these polychaetes, these worms, are also inhabiting the worm cracks where these octopus are brooding. We haven't sampled a lot of crustaceans thus far in the cruise, and during our last meeting there was some discussion about whether or not we should be collecting samples from that community as well. In particular, we do note that both here and Dorado, there are chemosynthetic shrimp, those white shrimp inhabit, there you go, there's one of them, the same places as the octopus. They, in some cases, have been very interested in their eggs as well. And I think we may be about to sample one of these shrimp.
The lasers are still on, right? Yeah. There you go. Okay, let's try it. We're in
All right.
chamber number 1,
Okay. Bless you.
Most delicate thing.
All right, so using the slurp again, this time focused on a shrimp. And there he goes. Oh, and yeah, we got 2.
Yep, he's in.
Yep, 2.
That's good.
Happy? Okay, index.
Great.
Now we're gonna explore.
Okay, we're on jar 3.
What about the wood?
Oh, we went backwards?
I wanted to fill them up.
Are they these things?
No, we got those. The wood?
Are you going
Yeah,
to
we need
the
the wood.
The wood. Yep.
The wood is going to be deployed now?
Yep. Okay, so the final operation here is in Firebox 2 is the bag of wood.
Are you happy to place this here, or should I jump on higher up?
No, I'm happy with it.
All right.
Currently coordinating the deployment of another experiment that's on board SuBastian right now.
All right, so it looks like the next operation at this location will be to put out our wood experiment, which is again another substrate, to see how these communities interact with it and potentially inhabit it.
So what we didn't do here, remember when we were at the top of this feature, how we still living? So we can go up there and spend a little bit more time looking at it around. And then, because we know that, and we didn't sample it, so we'll go up there. Yeah. Okay. Yeah. So yeah, I figure we'll go up there, because we just looked at it before. side of the center, so we can look around there. And then at some point we'll move to come to do the photo.
Are these all one bag?
All in back with that one up there. But not necessarily for microbes, grounds.
Okay, so we saw those experiments being deployed earlier. Those were microbial experiments with different substrates into those, inserted into those PVC sections, different ages of basalt, as well as sort of a control that I think consists of sand and beads, glass beads. In this case, this is a similar experiment, except it's now aimed at the macrobiology. So understanding whether or not communities of octopus and shrimp and other fauna in these vents are interested in colonizing these particular media. Yeah, and question about the pressure, just to talk about that a little bit. We are not quite at, we're at 2,800 meters water depth. The water pressure is so much higher than atmospheric pressure that there is negligible component of that is acting, it's not influencing anything at this depth, for sure. We do have tidal forcing, however, that you do see the signature of that in either pressure or temperature loggers deployed at the seafloor. Yeah, and technically, air is also a liquid. It's just a much less dense liquid and exerting much less pressure.
So once we've got that logged, I think I want to come away from this and get some nice shots of what it looks like. And then we're gonna go up this feature, up above the Taylor's field, and it kind of comes up, and then there's like some walls with a bunch of cement and an octopus. We want to spend some time looking at those. The photo is probably gonna direct some animal sampling. It's almost a sheer face, so I don't think we can really do temperature measurements or many collections.
Yeah, and tidal signature and tidal forcing will impact venting if the subsurface is permeable enough. And in this particular system, based on 2.5 years of running numerical simulations designed to emulate the conditions in this part of the world, we have verified that crustal permeability is very high. And as a result, any forcing or changes in pressure at the seafloor will influence venting behavior. So in terms of permeability, a number I like to talk about, or a property that I like to talk about, the permeability is about 1,000 Darcy's, if you're familiar with those units, or 10 to the negative 9 meters squared. So this is several orders of magnitude higher than it's been measured previously using other direct methods or modeling estimates. This is meaning there's a lot of water that can be throughput in these systems. And the result of that is a crust that is much colder than it should be based on its age. We know the crust cools after forming at the mid-ocean ridges. After about 1 million years, we call this off-axis crust, is blanketed in enough sediment that there's no free exchange with the overlying ocean and the upper layer of the crust, which is permeable. And all of that exchange is then taking place through these outcrops or seamounts that provide that hydraulic connection between the overlying ocean and the crust below that is separated by those sediments. Those sediments are acting as an insulating blanket that do not allow flow to happen. And in thinking about pairs of outcrops, which is probably the simplest way to envision the process of hydrothermal circulation, what happens is the cold bottom water that is very dense as a result of its temperature. At these depths, we're at about 1.8 degrees Celsius, so very cold, very dense. The density allows it to sink into permeable outcrops, making its way into the base of those outcrops that are connected to the crust, the upper part of the basement, that is made up of these pillow basalts that are very permeable. That circulating water will make its way eventually to another site that is a discharge site, another permeable outcrop where it can exit. And in that process, in its travels through the crust, if it spends a lot of time in the crust because it's less permeable, it can take up more heat and move that heat towards that discharge site. In this particular spot, the residence time of the water in the crust is fairly short. So the exiting water is between 6 and maybe 12 degrees, but the amount of fluid that is moving through that system is essentially washing that heat back into the ocean and leaving our temperature or our heat flow measurements registering a loss of heat. And that heat, again, is through that vigorous process of hydrothermal circulation where water goes in one outcrop and out another. Looks like we're heading up to the very top of this part of the outcrop.
Yeah, sure. Thank you. So these little wispy guys are our target that we want to try to collect. If we can. And as we get up here, things start to just like carpet the area. So if we were to pan up, you'd probably see more.
Just let me know where you want to sample and all that.
Okay, we were in this particular location on the last dive. We had to come to the surface earlier than planned
Or we might have to just pick up a rock.
and didn't have time to do any sampling.
So let's see these rocks.
Is there, you think they're up top?
This is probably one of the denser areas.
Yeah.
We have them right there. Might be able to snap them. So,
And what is different here than
Is it okay if I do
Yeah.
some zooms at 'em?
zoom?
Just to see if they're actually different. I think there's a couple of different species in here. I don't know, maybe they're all the same. Some are more white and pink.
Try suction first and then break.
yeah, I think you might have.
But yeah, this rock like right in the middle, it
Mhm.
looks like it might break off. Yeah, so let's try either that dense piece or the one where it's a little bit more bare with the little stars.
Yeah, so this sort of fuzziness that is present all over the top of this outcrop appears to be a different coral than we have seen, at least at Dorado. We're going to sample that, and it's just densely carpeting this whole portion of the outcrop.
Try breakage first.
I'm not, I'm just on the first slide. So I wonder, you don't just look at
So since we're on the slope here, the pilots are trying to figure out kind of how we're going to perch on the slope to get a closer look at this. If I kick over to our situation cam,
Seems like two different colors.
you can see that metal ram on the left side. We have one on both sides of the vessel, actually, on the port and starboard of SuBastian. And those can be extended out. And they've got a little bit of
Are they?
like a
Okay.
toothed grip on the bottom. And we'll
Just not as
frequently use
dense
those
in terms
to
of
brace
number.
ourselves against
Yeah.
slopes and cliffs. And sometimes you'll even hear the pilots bringing that in or pushing it out to adjust the distance from something that we are.
Mm-hmm. It's subtle, but they're definitely different. And those look darker down here.
Before we grab,
Yeah.
can we
All right.
get some close-ups?
Adam would like me to introduce the rams to the world. They are named by the pilots here as Rock'em and Sock'em.
Wow. Yeah.
Rockham's on the left and Sockham's on the right.
Rock,
We don't have Sockham on today because we have heat flow.
Rock'em is the port side and Sock'em is starboard side. But Sock'em's actually off of the ROV today because we have the heat flow probe in its place.
Can we get the lasers on for a moment? Okay, lasers on now, Wendy? Okay, let's try it.
I don't know, I was throwing out suggestions.
You want to kind of scrape it with the forearm and then try to
I'll try to get it.
like put starboard, like put
Put the suction like right there and then try to scrape out or just go in and grab.
I don't know what they're.
We tried to slurp these yesterday.
Yeah.
It did not work. They are very sticky.
Okay. So you think if you use the coral cutters?
Yeah, so they were able to use the coral cutters to pop them off. They're super tiny, as you can tell. So we could try that. I'm also fine with like most of these rocks have been pretty loose.
So apparently these are also found on Dorado, just not in as great an abundance in terms of they're lining these cracks near the top, the outcrop. So we're discussing how best to sample them. They are very sticky. Yeah, not sticky to each other, but sticking to the rock. So they had some difficulty in sampling them yesterday. Ideally, we can take a rock that is hosting the corals. Two for getting some of the geology as well as the biology.
I'll just get it centered like that and then I'll have
these rocks are loose.
Yeah.
That's me off. That's me off. Just have a grip on it.
Something just popped.
Yeah, let's just use snip.
So the rock there's a little too much, but in that camera view, you could see kind of how we use Rockman Sock'em to try and hold to the edge there.
You good? You did
Yeah,
all those
so,
things.
so we're not doing that here.
No.
Okay.
So no.
So, I'm
So if we find something like extraordinary,
Yep.
then we'll do more sampling.
Mhm.
Kind of going around the summit feature
Mhm.
and then eventually heading towards the southeast.
Got it.
Since it's only 400 meters away, like, I think we could do that around like 2.
Rob will be in here too. I'll be in here too.
Hmm?
We'll both be in here.
Okay. Yeah, we'll just start heading that way.
Cool. So a lap around, looking for.
Yeah, just looking for venting.
Yep. Okay, so I'm going to try another approach to sampling this coral. Obviously, all rocks we think of as hard, but some of them we can actually sample directly with the manipulator. In this case, we're going to use what are called coral scissors.
Yes, thanks.
Cool. It was a pleasure.
Always.
Yep, we're here. We're doing a little lap around the summit. Yeah. Yep.
Are we doing that at any point?
Yes, but it's not clear when. Yeah, I think we're waiting. Okay.
Okay. Cool. This guy down
So
here
we're
was
just being very careful with dimensions right now, seeing if we find
Yep.
high to five.
Exactly. Yeah, so once we've collected this sample, we will be continuing to do kind of a lap around the summit area, continuing to explore, looking for additional vent sites. Now, ultimately, we'll be heading down the face of the outcrop, following a slightly different path than the one we'd taken previously to expand our search. And what's exciting for me is that we also expect to do some heat flow measurements at the base of this outcrop. We did do 6 measurements along a transect on the top in a sediment pond that allowed us to make those measurements. Those of you who have seen that, we need at least a meter, or ideally at least, a meter of sediments that allow us to safely use our heat flow probe. Those measurements showed elevated heat flow, indicating potential venting or likely venting. We were very lucky to also find that venting on our very next dive. It can be very difficult to locate sites of venting on an outcrop. Yep.
Actually, the ship. And then Rob sending the
Yep.
waypoints.
We have a time before, after. And Yep. And so we were at this particular site during our last dive on this outcrop. Again, we're going to make our way to the base to collect some additional heat flow measurements along that seismic line. So we understand the subsurface conditions, the sediment thickness, and that allows us to better understand what is the signature heat flow you would expect for a venting outcrop, now that we know this one in particular is venting. We know the outcrop to the west of this that has been called, and in one paper, Caballito, is about 2.5 kilometers away. It is a larger outcrop than this one, and the larger outcrops tend to be recharge sites. They have a larger surface area, and that surface area affords both recharge, and local discharge, which is something we actually got to see on Tango Set earlier in this expedition.
There you got something inside.
All right.
Something in there.
It's not possible that you hold a piece of rock.
The rock didn't really work out.
Beauty.
All right.
You can zoom here. Just good zoom this as well. I can rotate it around if it gives you a better angle.
So we're going in for another small sample of this coral that seems to be prevalent at this site. Also seen this coral at Dorado, but not as prolific an example of its distribution. It seems to be all over the top of this outcrop.
Just put the jaw away and open it.
Yeah, and one illustration of the pressures that we're operating in at these depths was just mentioned. A lot of these cruises before styrofoam was banned in many countries, it was fairly easy to get styrofoam cups about the size of a grande cup from Starbucks, decorate it using markers. When you send it to the seafloor at these depths and recover it, it is about the size of a shot glass. And that is, a direct effect of experiencing that much pressure. All of the air is squished out of material, and what you're left with is a very rigid material that doesn't really resemble the original styrofoam in size or physical properties. And those are great gifts for people at home who are not with us, who have a little gift to remember this by. I have a couple in my office that I keep in my line of sight to remind me of the cool work that I get to do. Yeah, so this is just everywhere. It's a field of this coral. Hello.
Hi there, Alan. Nice to try you back on deck now. So we're going to bring the heading back around to start with. Around 45 degrees. Do you need us to
Yeah, I'll put your waypoint right about there.
Great, no worries. And I'll bring the head around. Thank you.
Thank you.
All right, we've got a bit of a pilot handover happening here. So for anyone who's just joining us, we're about 2.8 kilometers below the surface of the Pacific Ocean off of Costa Rica.
So the plan is
We are revisiting the outcrop
outcrop
that we were at
the
2
summit.
dives
We're
ago,
gonna do a little bit of
and
looking around, maybe some
we
probing
found
temperatures. We're trying to get
not only active venting
better
here, but
sense of
another
what
octopus garden, a nursery,
corals
where the females are all brooding their eggs.
which is down
So we dropped off some experiments at that site earlier this dive, and now we're kind of paused here while we take a look at sampling some of this coral. But then I believe we're gonna go explore a little more
I'm the only one.
and take more samples.
We're gonna do a little bit more exploring, maybe a lap around it, and then maybe. I mean, it's not that far to get to that waypoint. So little time. Sampling. If we see it shimmering, do some more. Yep, and then. Yeah, and that's if there's a new site, exactly. So it's all if then. Yeah, we hit 7 earlier today. Yeah. Yeah, so there's a lot. If there is another event site we haven't been to, because we're like on the other side of this or on the way down, because we're going to kind of head out. We haven't been on that line. Maybe then we get into all of this. Yeah.
There's a good look at the camera that we watch these things out of.
All right. So we are in the midst of ship change. So it's a pleasure spending an hour with everyone, and I'll be back when we do heat flow measurements at the base of the outcrop. Have a great morning.
Master 6.5.
So hi everyone, I'll be swapping into the next hour. I'm Emily Cowell, a PhD student from Temple University in Philadelphia.
And on that's 5.5. Alright, then should go find some good rock then. Yes.
Cool. Okay. I'll be snapping off a rock to try and get a coral sample. That will work anyway.
They say that it's not possible to break the door,
Right.
so they are going to try to scar
Okay. Cool. What are these called?
the coral.
Yeah.
It's a soft coral, but it's I think it's not that it's sort of neat. It's something.
Oh, okay.
Yeah.
Kind of an encrusting soft coral.
Yes, exactly.
Okay. Okay. So there's some interest in sampling this kind of white encrusting soft coral. All of these polyps that you can see growing across the rocks here. Oh, got a little octopus visitor. So we're just looking for an area. The rock seems very hard here, so it seems like we're maybe not going to be able to break off the rock potentially, but we'll see. But we're at least going to try and sort of scrape some of these polyps off. So the question in the chat about my area of expertise. I primarily focus on methane seeps, so slightly different to what we're looking at here, but similar in terms of some of the organisms that we find and the fact that we've got this fluid outflow. The seeps I've actually looked at are a little south of here, still off the Pacific coast of Costa Rica. But we're noticing so far that some of the fauna, like the crustaceans, does seem to be pretty similar between the sites that I primarily study and up here, so that's pretty interesting. Sounds good.
Just want to try with the other arm. Okay, okay, so stand by, stand by.
I want to see that rock will move.
You want what?
I want to see that rock will move.
Yeah, yeah, go for it. Sure.
So I think we're just seeing now if we can actually break off a section of this rock, since it seems sort of slightly separate to the rest of the formation, but it's looking tricky so far. Yep, there's a red brittle star just sort of peeking into view, top left. Whoa.
What else we got? Are you able to snip it off, or just be close in?
These are an interesting group of corals because unlike most corals that where the polyps kind of grow into a big, maybe a fan kind of formation, live in these big colonies, these seem to be individual corals that grow encrusting, individual polyps, sorry, that grow encrusting on the rocks and are connected together by a sort of network of little filaments. You can see when you touch the coral there, the polyps retract. So coral, for anyone that doesn't know, it's not a plant. Each of those individual little star-shaped polyps are an animal. In shallow waters, they have typically bacterial symbionts that are photosynthetic, that provide them a food source. In the deep sea, they usually don't have, or certainly the thinking is that they usually don't have symbionts because there's no light for the photosynthesis to occur. There is question about whether some of them have chemosynthetic symbionts, but I think that's sometimes still up for debate. But instead they tend to be sort of particle feeders. They'll feed from particles floating around in the water column. So I think we've changed tactic here, and we're just going to see if we can scrape a few of these polyps off the rock instead. Oh.
It's bigger than the other one, yeah.
Some more questions in the chat about the brittle stars as well while we're here. Yep, they certainly have the ability to move a bit faster than your normal sea stars. Sea stars move with their tube feet system that they manipulate with kind of changes in water pressure through a series of water channels. Brittle stars actually don't move like that at all. They sort of drag themselves across the sediment with their arms. They're very mobile. And they have even been seen kind of swimming around in the water column, which is pretty cool. just trying to get this bit of coral detached from the manipulator arm. These sort of squishy fingers on the right-hand manipulator are really useful for corals, although it does sometimes mean that they get a bit stuck. But you've got this kind of snipping mechanism at the back that's facing us that you can see that is used to snip the base of the coral, and then these squishy fingers allow you to hold the fragile section of the coral that you've broken off without damaging it. Each of the sub's manipulator arms has different sort of uses. The other one's much more like a metal claw.
Very interesting because everything is covered. Most of the rock are just in this place. So that's why we want to collect more samples.
Yeah. So we haven't seen lots of these in other places around this site?
No, not like this.
No? Okay.
So yesterday, but few, but probably different species. And the thing is that we need a poly for RNA, a poly for DNA, a poly for microbiome.
That's the problem.
So we
They're
are
so
run out of
small.
polyps.
Yeah. So I'm just being told by Odie here that she's particularly interested in this spot here for these corals because we haven't seen them in such high densities yet. We've seen corals that certainly are similar to this, at least yesterday, but just a few of them kind of encrusting on a rock. And it's tricky because they're quite difficult to get off because they're this encrusting type. But you end up needing an individual coral polyp for each of the things you want to do. So if you say wanted to do microbiome study, DNA extraction, you would need multiple polyps. So that's why we're trying to grab a few from this site before we move on. Looks like some sort of little polychaete there, polychaete worm as well, moving around in amongst everything.
Going to collect something like this is always a good reminder that we're frequently quite zoomed in on the camera, and it makes these items look very large, but many of the things we're collecting or attempting to collect are very small, and you're using a robot that's almost 3 kilometers away to try and collect these very delicate little things.
It always amazes me how responsive the equipment is to be able to be at those kind of distances from what you're sampling, but still be able to make these really precise movements.
Yeah. I mean, there's a question yesterday about how much lag there was, and maybe the pilots, like, is there really any noticeable lag now? Yeah. Well, obviously for your job, there shouldn't be any, right? But not even a really perceivable one, because there's what, 6 kilometers of umbilical, and
Hi,
it's
Steve.
fiber optic, so it's traveling 6 kilometers at the speed of light, essentially, which is nothing.
No, it doesn't look like it.
Yeah, let's go. Let's find something better. Let's go this one here, man.
Oh, that's a pretty big one.
Yeah, okay. Can you go up? Stand up, so that.
What's the best angle for me to get in here?
On the left.
On the left?
Yeah. Let's see. There's another one too, just in case you missed one.
Okay, once the table, I can actually ram in, she doesn't get all of us. That's the table?
Yeah, that one's fairly big.
Oh yeah.
So it looks like we're going for this pretty big coral polyp there in the middle of the screen, in the hopes that that's a little bit easier to get off. Especially with the position it's in, kind of hanging off the edge of the rock there.
That's why I even know that. Much better.
If we could do half hour, it'd be awesome.
Woohoo! Fantastic.
Real nice. There was a good look at the blades on the back of that manipulator there too.
And you can see the coral just peeking out the top of there, being held in those squishy fingers. So it's not being damaged too much by the manipulator arm.
There it
Perfect.
goes. Nice.
Well done.
There's another one. You wanna grab that one?
It's okay, but if you can take another one, because now you have to train.
It's a big one.
Yes.
We've decided to strike while Ben is all ready to go. try and collect one more of these, it sounds like.
Oop.
Very steep rock slope on our left there where we have the ram. You can see it just came into left frame there, and you can actually see that there are like a little teeth on the bottom to try and grip on that stone, but it's quite smooth over there.
Maybe after we take this one, we can that one. Going after this one.
Okay, great. Yeah, we're just going after these, just where the lasers are pointing now. We're going after one of those larger polyps there. For anyone wondering, those two green dots are actually 10 centimeter scale lasers. So it allows us to point the lasers at an organism that we're interested in and realize that that's 10 centimeters in width. So we can kind of estimate the size of any organisms we're looking at without necessarily having to collect them. It also helps because sometimes with their pressure and temperature changes, organisms look slightly different when they come up versus when they're in situ. So it's nice to get a good view of an organism before we collect it with the lasers on and off.
This is more, this is like our science camp, this is like best food, and this one's kind of more just for us. This one is better.
Mm-hmm. Looks like we're going for this one in the front here. It's actually a cluster of various polyps I can see from the brow camera view that we have in the ROV van.
Yeah, let's see, I can toss one of those over.
So yeah, just in the stream there, it looks like we've changed over to the brow cam. View quick. Just to give you an idea of the different viewpoints that we get. All of these different cameras allow the ROV pilots in particular to get various views from different angles. So they can sort of put together a more 3D picture of what they're looking at. And it helps them with depth perception when they're doing a sample. Again, sometimes it takes a bit of persuasion to get the coral polyps out of the manipulator. These squishy fingers are sometimes just too good. Don't want to let go. Do you end up having to replace the padded bits on this?
Yeah, we 3D print them.
Yeah.
Yeah, and so the
Oh, okay.
step that
So we're just going to, I think, do a loop around the top peak. Yeah, and we're looking for sites of 5 degrees or more. Yep. So once we've finished these samples, the next plan of action is we're kind of on the edge of a small summit here, where we've seen venting. So our plan is to look for more spots of venting around this area. So we're going to do a small loop around the edge of the summit, and any areas that look like they might have fluid discharge occurring. So far, that's been indicated by things like presence of brooding octopus or shimmering water, where you can see that the water is a slightly different temperature and density to what's coming out of the rock. And also areas of rock where the sediment has been sort of blown clean. So it looks like a darker area of rock because it doesn't have this lighter sediment lying on top of it. And if we find an area like that, we've got a high temperature probe that we can get out, and we stick the high temperature probe into the area and register the temperature. And if it's above 5 degrees C, we'll deploy a marker so that we can come back there in the future, perhaps in our December expedition. We'll collect a couple of the squeezer samples. So they're like a sort of big syringe, which allows us to up into the squeezer from a very specific spot, so right in the rock where the fluid's coming out. We'll collect a niskin, and that's a bottle located further back up on the back of the ROV, or on the side of the ROV. So it won't collect the exact sort of fluid flow that's coming out of the rock, but it will collect the water from the surrounding area. And then we'll deploy some samples. So we've got some microbio. We'll be collecting some rock samples for microbiology and maybe deploying a temperature probe as well. And possibly having a look to see if we can find a male octopus too. Oh, oh. Hey! Breathe now. Well done.
Yes. That's it too much.
Our nerves can't take it anymore.
Put the lid on.
Ooh. Perfect.
Well done.
Nice. So they're just pulling the basket of the ROV in there that has all the sampling chambers in it. And then we're going to set off and kind of go in a loop around this top peak. And just stick the temperature probe in various things.
Oh, do you want us to grab a temperature probe right now then?
I mean, yeah, I think that would be the first thing we would have to do if we spotted anything, so if it's easier. Mm-hmm.
See if it's a good time for lunch. It's always a good time.
Yeah, I think the next plan is just to go around in a circle around this peak and temperature
Scope it out.
probe some
Okay.
spots.
Sounds like a good time for lunch.
I would say so.
Yeah.
So this is the high temperature probe. We're just getting this out because as we travel around the top of this peak, we're going to be looking for spots in the rock that might be worth using the temperature probe. So I think we're going to have it out and ready.
Maybe we should come up with it.
I guess when we actually use it on something, so it's not yeah. Spots that look promising. I don't know whether these like tiny little. It looks very dark now. It seems very small. I don't know.
Want to try?
Yeah, just out of interest. So we're looking for those kind of darker areas, so it's worth a shot. It does seem like a very small gap, but it could be a small fracture that it's leaking out of. It does seem like it has no sediment really accumulating around the outside of it, so you never know. It's worth a shot. Yeah, just these holes with the sort of darker rock around them, just to see if they. It's hard to tell. I don't know if we can maybe do a quick zoom and have a look, but it's another indication is if there's no sediment lying on the rock around it. Yeah, could you zoom in? I don't see anything obvious, but could we just, while we're here, would it be quick to do that?
Yep.
Just because often where there's no sediment lying on it, it's sort of showing that there is maybe some coming out and pushing the sediment away, so might just be worth a quick shot.
Put in the hole.
Yes, please.
This one on top.
I guess that middle one, that is kind of the larger one.
Lower one.
The middle one would be fine. I think the larger one, maybe. Cool. Where's the temperature reading?
I can bring it up here, but Jim, do you have it on the just 1.82 right there? Oh, that might be CTD temp. Yeah, stand by.
Oh.
My temp out like 2.78.
Okay.
Actually.
Oh.
Oh.
Is it going up?
Three. Yeah. Yeah.
Round 3. So it is a little higher. The ambient is what, 1.82.
Yeah.
It's not as high as is justifying us taking a sample, but that definitely is a little bit. Oh, yeah, around 3. A minute. Yeah, we're near waypoint 1. But I think a lot of them are going to be near waypoint 1. Yeah.
Can you reach it?
Maybe at the minute we can just do whatever you think, and then I guess we can edit it after. But the highest reading I saw was like 3.0. Yeah.
Maybe not. For you always. How would someone focus?
Yeah, maybe that after.
Focus pen, but
Yeah, it seemed like we. I think that.
2 point, yeah, that was going up. Oh, yeah.
Oh, 3.22. Oh, this one's going up a lot higher. Okay.
4.
Oh, we're getting a different reading. Oh, we
5,
peaked
wow.
5. Well, hold on. This might be somewhere we want to get a sample then. Look at that.
Get a better angle, probably going deeper.
Mm-hmm.
Yes. Or is that good?
Can you use something like this? Oh, you don't even need that.
Yeah, those are very
Ram in here.
much higher readings than ambient, so there definitely is some fluid flow coming out of here. I think we're going to try and do it again.
Push one in.
Yeah, 3.08 we'll do the first one, and then we'll maybe do another. Oh, it's saying it's not here. It doesn't need an ID, but I think we were in the wrong place. Switching yeah, and then we do another one on this. Because this one seems to highlight. Okay, so when it reaches max on this one, then we'll record another. Yeah, so it does just show. It doesn't look like much, these little holes here, but seeing areas where of these kind of darker rock where the sediment's been blown away does seem to be a pretty good indication. 5.86 looks to be the 6.01. We'll keep it in there for just a little bit longer, maybe let it see if it goes any higher. I don't know how easy it'll be to get a squeezer sample in this tiny little gap here. I guess we can give it a go.
Yeah. I think you'll be able to do it.
Yeah, okay. Oh, because it has like a little hose on the end of it, doesn't it?
Yeah, it's got like just a small,
Okay.
not the hose anymore, but
Oh.
you should be able to get right over top of it.
Right, okay.
There's only, I think, the one left, which is number.
Can I pull that out? That right.
Okay, so 6.01 is for this one.
Done? Yep.
What do you want to put in?
Okay. Is it possible to
How are we using this? I think we have to pick
Oh.
up the squeezer.
hold on one sec. Beth's saying she doesn't want to squeeze a sample from here
Okay.
quite yet, I think.
All right. Continuing on then.
Just 1 second, I just want to check something in the dive plan first. Just checking, because it does say to deploy a marker if we find areas over 5, but since we're maybe not doing a squeezer sample, it's possible that she wants us to keep having a look around.
Yeah, you may have a hard time
Yeah,
with the marker here. I mean, we could, but
it's like they want to also collect like a rock sample. I don't see how you're going to
Yeah.
collect all of that, so maybe we can keep
keep going.
going, unless I hear otherwise from anyone in the meantime. So I think those areas of dark sediment are maybe
Off to the right there.
no, I was just gonna say maybe what to keep an eye out for. But yeah, maybe having a look around these kind of cracks and crevices around the edge would be helpful. So I guess that we're looking for like a bigger, I guess we're looking for a larger spot of fluid flow before we do all of the stuff, probably. Because it's like if we find above 5, there's loads of things we're supposed to do, but we didn't want it right there, so I guess maybe we'll look for a more substantial spot. At least. I think that's probably the way forwards.
For the player marker and
Yeah, like put a marker in this instance.
this is where we find like octopus space.
That's
That's
eventing
right.
side. Yeah.
That's what I think.
Yeah, I would say so.
See, okay, that's good.
So we're just keeping an eye out for any more promising looking spots for temperature probing around the edge of this site. We're sort of up at the peak right now, doing a little loop. So let's say indications would be shimmering fluid flow, areas of dark rock like the one we just saw there, where the sediment has been kind of blown away from the surface of the rock, or brooding octopus. All of those have been good indications so far. There's some big sponges on the side of here. There is an octopus. We can go and have a quick look while we're here, I guess. It doesn't look like it's brooding. And it doesn't look like it's in a obviously sort of fluid dischargey type of area, but we'll go and have a look. Typically when the octopus are brooding, we've seen them underneath sort of ledges or in cracks in the rock, but kind of upside down with their tentacles curled up over the tops of their mantles, which isn't what this one seems to be doing. Can we have the lasers off for a second, please? Thank you. Thanks. I guess, can we turn around and sort of just have a view of the side of these rocks here with all of these cracks and crevices? Yeah, I don't see anything really obvious right now. It's a very small sort of summit that we're just looping around, so it'd be nice to just take our time and look very carefully around the edges of here. be possible to drop down a little bit and just peek into some of these little sort of caves? Because it's tricky, because these will also probably not have very much sediment in them just because of the fact that they're a little cave. Maybe we can keep moving around the edge. Ooh. A little fish living down there.
Bridge, updated position.
Updated waypoint, thank you.
Some really interesting rock formations here, lots of overhangs and quite complex structures. Oh, some sort of huge galatheid peeking out from in there as well. Those galatheid squat lobsters. Oh, there's an. Can we have a quick look at that octopus just to see what it looks like it's doing? A fish. Actually, is that an octopus? might also be a sea star. My eyes might be deceiving me, but we can go and have a look. I think it might be a starfish. I think I might just be blind.
I thought it was the tooth at first.
Maybe we can have a quick zoom just to be sure. I think it's, yeah, I think it's a sea star. False alarm. Wow, look at this urchin on the right there. That's cool. These really long, intense spines. Look at that. Isn't it cool? Oh. That fish nearly got itself impaled on the urchin. Has to be careful. Zoom on the urchin? Yeah, sure. Yes. Can we have a glamour shot and some lasers on and off and things of this urchin while we're here? Thank you. Very cool. Uh-huh. Do you want like a still shot for a second before the lasers? Yeah. Yeah, that sounds good. Yeah. So we can just have that view for maybe 5 seconds or something and then put the lasers on.
Yeah, sure.
Thank you.
Ready?
You can see it moving its spines. That's cool. There are the lasers there. So the actual main body of the urchin's not that big. Maybe 3 or 4 centimeters across, but with those spines, it's probably more like 25 to 30 centimeters across. Perfect. Are you wanting any more views of it? Happy with that? Okay. Okay. I'm going to jump off now. But it's been a pleasure. Thanks, everybody.
Good afternoon. Hello, Lorraine. I am here.
Good afternoon, good evening, good morning. This is Jorge Cortez from University of Costa Rica. I'll be here for the next hour. And with me annotating is Myla from Brazil. Muy buenas tardes, buenas noches, buenos días. Les habla Jorge Cortés de la Universidad de Costa Rica. Voy a acompañarlos durante la próxima hora en este sitio. Y me acompaña aquí haciendo anotaciones Myla, que es una estudiante de Brasil.
Es Octopus oceanograma de cualquiera que haga, de los grandes.
De cualquiera.
De los híbridos, de los grandes. Un programa que tenga por lo menos una ramificación.
When we were, once about an hour ago, we were basically back here. I think this is all they've done. This is where we hit bottom.
Hello, Chris.
Hello, hello. How are you?
Good, good.
Chris,
Yes.
you want to do a comp?
We can do the comp look. Are we okay to turn the camera around a little bit? Are you okay with that? Sorry. If we turn the camera.
Yeah, that's fine.
It's on Q1 at
Every rotation. Alright, if we want to turn those lowers off, I get it. Boom. And then I'll open up the
names.
1 second. Can you read the left one?
Did Emily talk to you about the map?
No.
Okay. It's easier to see on Scott's, but this is fine. Where it says waypoint 1, that's where we were spending most of the morning at that spot. And then they've come up and over. And the idea is just to explore around this pink area, maybe coming around the south, and just seeing if there's any more evidence of venting. There was one other spot that we saw 2 days ago that was like under a ledge,
Just 6, yeah? 6.6.
but it's probably a relatively small feature. So I think we do this for another hour, just explore. Maybe if we see things, so we've already, for instance, gotten this. We got those. We got so if there's other target species we see associated with venting, then we should try to collect them.
Okay.
And then in about an hour, I think we'll move on to just doing some standard transects and then go to this one, so that we have enough time to get out here and do those measurements.
Okay, great.
Chris, is there a way to increase or decrease the snail trail?
Hit quick draw.
Oh, is there a way to increase it once it starts going away?
Oh, not that I'm aware of.
Okay.
Yeah. I think that once it starts to give up the ghost, it's
It is what it is?
I think so. I've never thought about it before, so I can't really say 100% that's true.
Yeah, okay. That was just asking, but I'm pretty sure this is descend. It bottom came up, sampled, and then it's like this is basically all we've done this launch. I mean, this whole shift. Done. Yeah.
You heard what's the idea? We'll go around the pink area.
Okay.
To south, southwest. Yeah. And then move around and see, and this side, this is some ledges.
Okay. Yeah, go ahead and start doing that now.
Mm-hmm.
All right.
Lasers on, you said?
No. So.
So and look for evidence of venting.
Look for cool stuff.
The warm stuff.
Okay. All right, fair.
Okay, we're gonna start moving here. Here sitting with me is Chris, pilot, and second pilot is Mike, and Alex at the other end with the comments and guiding us through this dive.
Can you bring up your sonar for me?
Yes.
A bit different terrain up here than what we had down at the nursery.
Stuff in the water. Okay.
Those are, yeah, organisms that we're seeing in the water. It's not dust or anything. It's little creatures, little animals, like crustaceans just passing by. We've seen this a couple times before. Aquí lo que vemos son organismos nadando. Van pasando probablemente unos crustáceos pequeños. Ya hemos visto en varias partes y a veces parecen los sedimentos que se levantan cuando se mueve el ROV. We're going to go around this summit of this outcrop, looking for venting and checking out the organism. Let's see that guy, the sea urchin. I mean the sea cucumber.
Chris,
Chris,
I want you to zoom
here.
in.
Oh, which the one?
This one here.
Oh, okay.
It looks like one of these we're looking for. This side is about over 200 kilometers from the Pacific coast of northern part of Costa Rica, of Guanacaste, and we're here at let me see, 2.81 kilometers, and temperature out there is 1.8 degrees. And we're can see an octopus there, and we're gonna check out a sea urchin. Bien, aquí estamos en este afloramiento rocoso. Está más de 215 kilómetros de la costa pacífica de Costa Rica. A 2.8 kilómetros de profundidad y con una temperatura allá abajo de 1.8 grados centígrados. Estamos aquí instalándonos para hacer unas tomas de un pepino de mar. And then once we settle, we'll take a look at that also. Okay.
There you go. Sorry about that. On the left.
Okay, yeah, we've seen this sea cucumber before. Yeah, we're looking for specifically for 3 species. This is okay. Yeah, we're looking for this one. So I thought it was one of these.
Okay.
Yeah, we have that one already.
Okay.
Let's see the sea spider. Take a look now at this sea spider. Vamos a enfocar esta araña marina, un picnogónido, sobre una esponja silicia.
Come on, buddy. Focus for me. I'm trying.
Beautiful. Oh, wow.
You can see their little claws.
Yes, yeah. Haven't seen that before.
No, that's cool.
Yeah. Okay. Yeah, and we'll do one with the lasers to get an idea. Yeah, it's a beautiful pygnogonid. It's related to the spiders. It's called a sea spider. Standing on top of this glass sponge, you could see the spicules sticking out. These are made of glass, and if you touch it, it's like getting a piece of glass in your arm. Oh, there you see, it's a little over 10 centimeters. Great. Yeah, it's very impressive to see these animals with these details so close up. Aquí estamos viendo una araña de mar, está relacionada a las arañas terrestres. Es de un grupo que se llama los picnogónidos. Podemos apreciar la cantidad de detalles que normalmente no podemos ver como un animal preservado, además del comportamiento. Y aquí está sobre una esponja de vidrio y se ven las espículas que salen de la esponja. Esos son como pedacitos de vidrio, y si uno los toca se le entierran en la piel y es doloroso. Very good.
Really nice picture.
Beautiful.
It's creepy, but it's a nice picture.
Yes. Yeah, 4 meter high.
Yeah.
Scary movie.
Was that movie, Casper Van Dien?
Oh, Starship
Starship Troopers, yeah.
There's an octopus hanging out on the left there. I don't know if
Yeah, it was our first look. We looked at the concept, yeah. And my comment, I was like, Now it's like, oh yeah, look, an octopus.
No, I like those picnic eyes. They are creepy looking, but
I will keep moving for looking for venting. Vamos a continuar desplazándonos a ver si vemos evidencia de salida de fluidos un poco más calientes. Recuerdo aquí está 1.8 grados centígrados y hemos llegado a medir fluidos hasta máximo en esta expedición ha sido 15, 12 grados, 10 grados. Entonces nos interesa ver esos sitios.
This is the top of this model, right? Make sure for fly around too far.
So here we see some sponges and the octocoral, these Antomastes. And probably if we look very closely, we'll see more organisms on the rocks. Aquí vemos unos esponjas y los octocorales, esos rosados que están de grupo a los Antomastes. Y probablemente si nos acercamos más, vemos más organismos en las piedras. Wow. Walking on the spines. Vemos un erizo de mar caminando sobre las espinas, que es muy curioso. Normalmente usan unos pies tubulares y se ayudan con las espinas, pero este está totalmente despegado del sustrato.
Put him with a handle for the central sector.
Oh,
going to put the map up so folks can kind of see where we are here. In our navigation, we are by waypoint 1. Doesn't always line up in a way that you think. The pilots keep track of it. You can see we're just right up above the point there, kind of circumnavigating it.
Our priority now is, as Alex said, circumnavigating this rocky outcrop and looking for the seepage of warmer water. Entonces ahora Alex explicaba, mostró el mapa de dónde estamos en este afloramiento y vamos a continuar desplazándonos en busca de esos sitios de emisión de aguas un poco más caliente. Lo que hemos visto es que alrededor de esos sitios se desarrolla una cantidad de vida impresionante. Estamos enfocándonos en una estrella de mar. Wait.
They're basically below us. Back off a little bit and see if that changes the deeper we go. Before we do that, though, what is that guy to the left? Oh, never mind, it's just another one of those.
I have a question of what's the downslope look like. So I'll pop this back up real quick, and you can see there's almost 2 layers here. We've got the real flat plains, and then definitely a more gradual slope down here that almost just flattens out. And we're hoping to take some heat probe or heat flow measurements, excuse me, a little later. So I anticipate us getting to a less rocky area for that, hopefully. But for anyone that's just tuning in, or you think that maybe that map looks a little familiar, this is the unnamed, unexplored outcrop that we previously visited about 2 dives ago. And during our last visit, we found active venting, as well as another octopus nursery, or they're getting called octopus gardens, where we have these female octopus all brooding their eggs in sort of that strange upside down posturing that we've seen. For this dive, we went back to that location. We dropped off some experiments, and now we are doing more exploration of the outcrop. As you can see on the screen, this is about 2.8 kilometers below the surface, and we are off of Costa Rica in the Pacific.
Sí, aquí seguimos viendo este afloramiento rocoso y algunos organismos, y se ve que aquí hay más sedimentos que en otras partes. Eso interfiere en el asentamiento de organismos. Y aquí viene un pulpo nadando. Here we have a swimming octopus settling down.
Just amazing the things that would be the highlight of an entire cruise in a different situation. We're just like, oh yeah, here you go. You want to take a look at them or? Okay.
Let's take a close look. Yeah. Janet is here. I'm gonna take a close look at this.
Could you turn the lasers on just for a minute, please?
Vamos a observar este pulpo. Nos acompaña ahora la doctora Jan Hoyt del Museo, el Film Museum de Chicago, que es, ella es la autoridad mundial de los pulpos.
What does that posture mean? Does it mean anything?
Come at me, bro.
We're at the lasers.
Yeah, you two are not gonna. I think that's not chemicals up yet. We're still moving around a bit.
Okay, thank you.
There they are. Yeah. Wow. It's big, huh? Why is that posture? Jen?
Pardon?
The posture. What are they doing? Sit like that?
I think they have chemoreceptors in their suckers, and when they put their arms up, they're sniffing the breeze. I think.
Esa fue la.
She's just stretching.
Yeah, this would be a roaming female then, right?
Right.
Yeah. So you can see that all the arm chips are the same, whereas we would normally be looking for a modified arm tip on the males. So on the third right, yeah, so that's the one you're pointing at. It's got a little curl to it right now. From the left side of the picture, it's the second in along the bottom. The one in the one at the bottom right now with the little curl on it. If this were a male, that last section would lack suckers and be a modified arm tip.
Carry on.
Aquí vemos una
Nice eyes
hembra
there,
de
yeah.
pulpo, y aparentemente cuando levanta los brazos así, está como oliendo el agua, tiene receptores químicos, quimiorreceptores en las ventosas y de esa forma detectan si hay animales, si hay otros miembros de su especie. Y vimos que es grande, como unos 30 centímetros.
No, I've had the opportunity to sit down and chat with you a lot, so it's good. we've seen males doing this pose as well. Someone asks, we've seen males and females doing this pose, I think we're that kind of sensing.
I think so. More often it seems like I see males do it than females. That she just landed, so she may be like scoping out where she's at.
Yeah. So if you didn't quite hear that, someone asked males and females both strike that pose, perhaps. And yeah, we've seen, Janet mentioned that it seems like we've seen males doing it more, but that one there being a female that we kind of just saw like glide in and land, if it is in fact them using the chemoreceptors under their suckers, she could be trying to get her bearings or figuring out where everyone else is. Confused by the giant bright light in the sky. Yeah.
Yeah, no evidence of bending around here. We'll continue circumnavigating the summit of this rocky outcrop. Meanwhile, we'll join the view and all the creatures that we're looking at. Si no vemos evidencia de flujos saliendo entre las rocas, y entonces continuamos circunnavegando la cima de este montículo. Rock looks like if it has something written.
Yeah. I would hit on that.
Yeah, that's over.
Yeah, it looks like, yes. Maybe it's, no, it's not a rock. I wonder what that is. I'm not sure. The texture is different. Could be a tunicate.
Yeah. Alien face.
It's a predatory tunica that's upside down.
A tunicate, huh?
I saw a few of those yesterday or the day before. How I describe this.
It's a tunicate. So it's a group related to us biologically, and holding on from that probably octocoral or black coral that's completely covered with sea stars. Estamos viendo es un tunicado, que es un organismo que está en la misma línea evolutiva en la que estamos nosotros, y ahí lo vemos que está prendido de un octocoral o un coral negro, y ajá, y en eso ese octocoral lo que lo sostiene vemos una gran cantidad de estrellas de mar. Yeah, right in front of us, they look relatively clean.
Pulled 3 hard last night. Yeah, really hard.
I don't see any shimmering there.
Can you bring the ship southeast? Just like kind of due east from waypoint 1. East. Keep on a little more. Yeah, keep on. No, just east. East of that hub. No. Is it? Great, ROV, got a new waypoint for you.
Yeah,
Thank you. Good one.
Or communicating with the bridge, coordinate the position of the vessel with the ROV. Periódicamente se comunican con el puente, cuando nos estamos desplazando, se comunica con el puente para coordinar la posición del barco con el vehículo.
I'm going to come around and let the vessel get behind us so that I can continue around this corner.
Ajá.
It'll be a safer place for all involved.
Ya le dieron una posición para el barco y ahora el barco
We'll come
empieza.
back and look at that in just 1 second.
Ajá, ok. Y el barco entonces se va acomodando para asegurarse que el cable esté bien entre el barco y el vehículo. Claro, ROV, que son las letras en inglés para un vehículo operado remotamente. Yeah, right now they sent a new waypoint for the vessel for Falcon 2, and so that it's always at a position that the cable will be in best way to connect the vessel with the ROV.
From the storage for backing.
I don't know. Looks like a sponge. I think so.
Cat's walking stick. Alright. The ship is moving in a good spot, so we'll come back down to the other side here.
Yeah, we've seen that sea cucumber before, and now we have collected it, and it's going to be studied by specialists, classified. Plus, its microbiome. It's also going to be studied. And yes, we see amazing organisms in every dive. Ahí veíamos una esponja recubierta de estrellas de mar y un pepino de mar morado. Ajá. Y a esos pepinos se les colecta para estudiarlos y también se les estudia las bacterias, el microbioma que vive en su intestino.
So obviously we had venting at the Octopus Garden a bit further down, but now we're kind of looking around for more venting on this outcrop.
Let's take a look.
Interesting hole in the ground here.
Yeah.
The last time we were here, we found that whole thing.
Oh, okay.
Yeah, that one, and that little depression up there.
Okay. Oh, so we've already checked this well out.
A couple times ago, yeah.
Or maybe nobody's home that day.
Do it again.
Yeah.
Uh-huh.
What is this hole?
You should hold the temperature with that hole.
Yeah.
The other day, it was measuring it like that. Okay.
We're going to measure the temperature there.
You want to probe it again, or just looking at?
Well, let's measure. Let's do a measurement of temperature.
Okay.
Doesn't seem to be too much.
Can you get a little closer?
This is like a pro, but I think it stick is different. That's the problem. Yeah. So this is the one that we have been using previously, right? So this one is new.
That's Excalibur.
That's how.
Yep, so this is a hole that we took a look at earlier, but there is shimmering.
Is it the same one? I think we've seen several.
Yeah, this is where we came up, the
Is
first
this
dive.
where we first spotted the
okay.
shimmers, I feel like?
First time we found it. So we haven't found any other big spots with octopus.
Want a measurement here?
No, because we got one the other day.
Okay.
Um,
Let's continue going around.
All right.
yeah, let's see.
You can see now the temperature is pretty low. That's the temperature that it's death. And I remind you, it's pitch black. We see all this because there are lights on the ROV. Sé que estamos viendo el sitio por donde estamos. Vemos el mapa, una figura 3D generado de la batimetría que hemos hecho. Y seguimos dándole vuelta a la cima.
So, okay. Since we have essentially circumnavigated the summit between the first dive and today's dive,
Okay.
I'm wondering if we want to maybe move to do some kind of standard transects going from the little further downslope up towards the summit,
Okay.
just so we get some kind of standard images of what animals are here. And then we can
Okay.
come over to the side with the octopus and do something the same.
That would be great.
Yeah?
Yeah.
Okay. I don't know if you heard that.
Yeah, so we'll come down.
Yeah, just come down a little bit and then maybe we'll do like a 50-meter transect. And kind of set it up like we have 1 meter off bottom, camera set at a particular angle with the lasers on.
1, 2.
And then 1.2, and just kind of pick a heading, like maybe from south to north. And then we'll pop over to the area where we spend all of the time at the beginning of the dive, start down below that, work our way up, and then just kind of get standard imagery going on both sides.
All right. Follow this down. Let's get to a flatter area down here. I'll go north and then go back. Come back up.
Yeah, sure. That sounds good.
I'll give Tony some time to get behind this a little bit.
So you heard some coordination between the science party here and our pilots.
We'll do that with the lasers.
Kind of figuring out what we want to do now that we've circumnavigated sort of the top here and haven't found any further venting. So they're currently putting together a plan of it sounded like some transects. Singular transect. All right. A single transect. So these are going to be kind of traditional transects. We'll have the camera sort of locked in a singular angle. The lasers, the 10 centimeter scale lasers will be on. And we're just going to drive a straight line. We won't be stopping to collect anything during this.
Nos preparamos para hacer unos transectos. Eso es una línea fija. Seguimos un sendero con los láser y así podemos determinar las densidades de lo que hay aquí. And
No.
The camera set right at the edge of the basket.
Yes. It'll be just so the basket and everything on it is just out of the shot.
Perfect. And the lasers. Yeah. Yeah, when you start, let me know.
Yeah, as soon as Tony gets into a position that's safe for us to.
Okay.
Is that the forum that somebody wanted this photo?
No, it's another one.
Yeah.
So we're waiting now for the vessel to come into position. Once it's in the position, we'll do the transect. Ahora estamos esperando que el barco se ponga en posición. Como expliqué antes, tiene que estar en una posición con respecto al vehículo para que no vaya a haber problemas con el cable. Que estamos a 2.8 kilómetros, pueden imaginarse, por el ángulo debe haber casi 3 kilómetros de cable allá afuera. Entonces hay que controlar la posición del barco, la posición del vehículo, para que no haya problemas.
Auto, that's what we had before. That's pretty washed out. We'll see when I get down to the seabed now. You want me to transect across this face, or you're gonna try to find flatter? See that?
Mm-hmm. Yeah, and we try to do it about 1 meter from the bottom. Ellos lo miden. Sí, pero hay que recordarles, ¿verdad? Que avisan cuando empieza y cuando termina para que quede registrado. No, estamos acomodando el barco para hacer transectos.
Sí, pero...
Sí, que se tiene que desplazar a ese punto.
While we're getting set up for this transect, for anyone who maybe just joined us, we are just over, we're about 2.8 kilometers below the surface of the ocean. You're watching live footage from the remotely operated vehicle SuBastian being piloted from onboard research vessel Falcor 2. And we're at an unnamed and previously unexplored outcrop off of Costa Rica. Currently setting up to run a transect about 1 meter from the bottom. Just seeing what we see. Going in a straight line. In this outcrop, we visited here, 2 previous dives. We kind of cut across a little valley for one, didn't find anything, came up the other side on the second dive, and came upon an octopus garden, or an area where there's active venting, and a species of octopus is brooding their eggs there. So we spent some time dropping off experiments at that site this morning. Then we spent more time doing some collections, just went around the peak a moment ago looking for more venting. And as I mentioned, we're currently getting into position for a transect now.
So right now I have to wait for the rest to be in position. I don't know what's going on.
Something to keep in mind always during these dives is that there is an umbilical tether connecting ROV SuBastian with research vessel Falkor 2. And it can take some time for Falkor 2 to get into position, and we'll give them a waypoint, or the pilots will give them a waypoint. And then as we're moving with SuBastian, the pilots need to update those waypoints. So we're currently waiting for Falkor 2 to get in position.
Going back to the northwest. Yeah, I need to go to the southeast. Wait.
Yeah,
all right, thanks, man. How you doing? Ready for action? That's the sun. That's the sun. The line of the sun. I was gonna come up. Dead. That's fine. I'm gonna come up this just because of the position of the vessel right now. Maybe it's not. And then we're gonna come back down to the seabed. Are you taking my footage?
Yeah, I'm flying now.
Okay. So we're gonna do a transect, about a 50-meter transect, and then once that's done, then we're gonna go back up towards where everything was, which is around 3.1.
Yeah.
We started to move him to the southeast, but then he started going back to the northwest, because that was a danger area for us. So I'm coming back up right now to make sure that we're in a safe place while he moves back to the south area. As soon as he moves over there, you can come down to
Continue preparing for the transect. Coming down.
Still, we're
Coming.
we're
Yeah.
still, we're still waiting for the vessel to move.
Okay. Still waiting for the vessel to move. Meanwhile, we look at what's out here.
The meter transect was from
Wherever, no matter.
yeah, it's not.
But north, south and north.
Yeah.
So, I don't know. Yeah, we'll do 2 and. Current position is northwest.
Looks like we've got a couple handoffs that are going to happen here before we start the transect. So you might hear some shuffling around and moving of seats and the like.
Yeah, so this right here goes up.
Always do want to thank folks that join us for these dives. You can be watching us live either on YouTube or Facebook. If you are watching live, of course, there's chats on both those platforms that you can type your questions into, and we try to answer those when we can. But we appreciate folks coming along and exploring with us, and it's quite fun for me to be able to share this for sure. I enjoy this aspect of bringing deep sea research live as it happens to folks around the world. And we do have a pretty good variety every once in a while. It's nice to see where folks are viewing from. Every once in a while, we get a little wave of folks coming online as maybe the sun starts to rise in their part of the world. So wherever you might be, thank you for exploring with us.
Okay, this is Jorge Cortez from University of Costa Rica saying goodbye for today. And my colleague and friend, Dr. Celeste Sanchez, also from the University of Costa Rica, will take over. Bueno, me despido de ustedes, Jorge Cortés de la Universidad de Costa Rica. Los veo mañana, nos oímos mañana y le doy el espacio ahora a la doctora Celeste Sánchez de la Universidad de Costa Rica. Un gusto haberlos acompañado en esta tarde. Bye bye.
50 meters that way and then up to 1 to where all the octopus are. That's the plan.
Two on this side, take your two on the other side. Dos de este lado y dos del otro lado. Two 50-meter transects on this side.
Okay, so what sort of direction like this? The map there, 50 meters. Straight north. So there. 6.5. The rest is 6.5.
Maybe like north, west.
So north. So one straight north past waypoint 1? Or
more to the west.
More to the west. Third is 6.5. The electrics is so there.
Yeah.
And then from there back down the other side.
Back down. This is the same type of environment, and the other side is where it's lengthened, so there's a lot of sponges. And do two on the other side.
Okay, so this is the area where there's a lot of action, right?
Yeah,
So from this marker, where would you like to go? 50 meters again from here, or
yeah,
here? Okay. 50 meter there. And another one going up. Did you say another 2?
And then move around a little bit to the shimmering side.
Again, we're just waiting on Falcor 2 to get in a position, but Jorge is currently going over the plan with the new pilots. We've currently got Mike in the pilot seat and Chill's next to me in co-pilot seat. And I'm in data logger seat. My name's Alex. I'm the multimedia technician on board for this expedition. And we're just in the middle of a little handover and getting ready for a transect.
Yeah, the one north first and then back down. By the time we're up there, the rest will be. Yeah, we're up to start.
So are you ready in position to start?
Yeah.
Okay, then we can start and then we can start to record it. Yeah, thank you. Good afternoon, everybody. My name is Celeste Sanchez from the University of Costa Rica. I'm going to be with you for the next hour of this dive. We are exploring an unnamed seamount that is located east of the feature Caballito. And right now we are just going to start to conduct a transect of 50 meters long So at this point, we will just basically transit about 1 meter off bottom in a straight line at a steady speed. So we won't be able to stop to collect any animals or to do any zoom. And as you can tell from the picture, we are actually also using the lasers. Remember, the lasers are a scale. There is a distance of 10 centimeters between the lights, and that helps us to actually identify what or estimate the size of the different organisms. Buenas tardes a todas las personas que nos están acompañando en este buceo. Mi nombre es Celeste Sánchez Noguera. Soy bióloga e investigadora de la Universidad de Costa Rica. En este momento estamos comenzando a hacer un transecto en este monte sin nombre que se encuentra localizado al este del monte o afloramiento Caballito. Y vamos a realizar un transecto de 50 metros a aproximadamente una altitud de 1 metro por encima del fondo submarino. Como pueden ver, estamos movilizándonos a una velocidad constante y estamos además utilizando como referencia los láser. Recuerden que la distancia entre cada una de las luces es de 10 centímetros y esto lo que nos permite es hacer una estimación del tamaño de los diferentes organismos que estamos viendo en el transecto. En este punto donde estamos trabajando ahorita vamos a realizar 2 transectos de 50 metros. Ahorita acabamos de comenzar el primero. Y como parte del transecto lo que queremos es estandarizar la toma o el video. Entonces no podemos modificar la altitud a la que se encuentra el submarino ni la cámara. Tampoco podemos hacer acercamientos, sino que tratamos de mantenernos lo más similar posible. Esto después nos permite hacer un análisis cuantitativo y cualitativo de los videotransectos que se realizan. Lo que estamos ahorita observando en el transecto son varios tapetes de octocorales, un equinodermo, una estrella de mar también. Pero este sitio, este flanco en el que estamos en este momento desplazándonos, en realidad es un sustrato de rocas cubiertas por sedimento y también por varios octocorales. Vemos algunos organismos como este camarón rojo que acaba de aparecer al lado izquierdo, pero en su mayoría son tapetes de octocorales lo que estamos viendo en la imagen en este momento. Estamos ahorita a una profundidad de 2.800 metros con una temperatura de menos de 2 grados Celsius o grados centígrados, explorando parte del fondo marino de Costa Rica. So we are just now conducting our first 15-meter transect, and as you can tell, there is basically a mat of octocorals in this area. In order to analyze the video transects later and to recover data, we have to keep a constant speed and also try to maintain the altitude of the submarine very stable, about 1 meter off bottom. Estamos cercanos a llegar al final de este primer transecto que estamos realizando, y una vez que lleguemos al final del transecto de 50 metros, los pilotos van a reposicionar el submarino para poder comenzar el otro transecto. Acabamos de tener un cambio de turno, así que en este momento los pilotos que nos acompañan son Mike y Carl. Y como uno de los técnicos de multimedia tenemos a Alex también acá con nosotros. Y en el puesto de tomadora de notas tenemos a Mayla, que es la que se está encargando de realizar todos los ingresos en la bitácora digital.
Okay, that's the first
The,
part complete. We're gonna
okay,
head
to the second. Yeah, thank you. So we just finished the first transect, this 50-meter transect. Now the pilots are going to turn around the ROV SuBastian and start the second 50-meter transect.
So this one has to go backwards because if we turned around,
Okay.
It's going downhill so fast you won't see anything.
Okay.
So we'll just
Go reverse down. Okay. Yeah. I mean, as far as we keep the same altitude from the bottom and.
It's the only way we can.
Yeah.
This way it would be much more altitude on the front.
Yeah. Yeah, that's right. Okay, perfect.
Ready to start.
So just let me know when you actually started so we can record it.
Yeah, we'll start now.
Okay, so you can start now. Maya, thanks. Vamos ahora a comenzar el segundo transecto de 50 metros y de hecho los pilotos del submarino nos informaban que lo vamos a tener que hacer hacia atrás porque para ubicar al submarino en la posición adecuada que requerimos para el transecto es mejor hacerlo en esta dirección, en esta posición. Así que en este momento nos estamos desplazando hacia atrás en un transecto casi paralelo al que acabamos de terminar. Les recuerdo que estamos realizando transectos de 50 metros de distancia con una velocidad aproximada de 0.1 metros por segundo. So we are now just doing the second transect of this side. And as you can tell, we are actually doing the backwards because it's better or easier for the submarine to do it this way in order to have the right angle of the camera that is required for the transect. Muchísima de la información que se genera en este tipo de expediciones no es información que se procesa en el momento, sino que después nos esperan horas e incluso meses de trabajo frente a la computadora para poder analizar todo este material digital que se está generando. Entonces, van a haber personas que van a tener que encargarse de revisar estos videos y ir, digamos, analizando qué fue todo lo que se cuantificó en los diferentes transectos, identificando especies, tratando de hacer estimaciones de tallas también. Eso nos permite posteriormente hacer una, digamos, caracterización cualitativa y también cuantitativa de estos lugares. Como les comentaba al inicio, para poder hacer una estimación cuantitativa es muy importante que los transectos sean todos exactamente de la misma distancia, en este caso 50 metros, y que además se realicen en las mismas condiciones, con el mismo ángulo de cámara, a la misma distancia desde el fondo marino y con la misma velocidad de navegación también. So we are right now about halfway of this second transect. And once we finish with the transect in this area, we will move to the other side and try to do 2 more transects near the venting site. We can see in this transect there is an octopus and more echinoderms that we had in the previous one. Una vez que finalicemos el segundo transecto que estamos realizando en este momento, vamos a desplazarnos hacia el otro sector, más cerca de las emanaciones de agua caliente, para poder hacer 2 transectos ahí y entonces poder caracterizar ambos sitios. Como pueden observar en este segundo transecto, la geología es diferente, es un poco más irregular y también estamos viendo diversos organismos. Acabamos de pasar un pulpo, hemos visto varios equinodermos, varias estrellas. Ahorita en pantalla tenemos algunas esponjas y el transecto está pasando de hecho justo por uno de las cuevitas que vimos ayer, donde, o hace 2 días, si no me equivoco, en el buceo de este sitio, donde había indicios de mucho cemento del que utilizan los pulpos para adherir sus huevos. It feels like that one was longer, right? Or no?
It's because we're pretty much just in the
okay.
steep face.
Yeah.
I mean, I don't know if you want to keep going back to the marker, if you want to shorten it a little bit, just looking straight down.
I mean, if you set the marker for 50 meters, then we just like probably end the transect there, wherever the 50 meters are. Yeah. Estamos viendo en este momento un pez que aparece también en el transecto. Usualmente donde tenemos ambientes con mayor tridimensionalidad, suelen también haber más organismos asociados. Entonces, por eso es que pudieron ver que la biodiversidad del primer transecto, donde el fondo o el sustrato era un poco más plano, más constante, era también diferente a este segundo transecto, donde tenemos una mayor tridimensionalidad del sustrato. Vemos ahí un par de crinoideos sobre una esponja de mar muerta ya. Les recordamos que pueden seguir todas las transmisiones de los buceos en los diferentes canales del Schmidt Ocean Institute, tanto por medio del canal de Facebook como del canal de YouTube. Y también queremos invitarles a que visiten el sitio web, donde estamos publicando blogs cortos escritos por algunas de las personas que están participando en esta expedición, tanto científicos como también los 2 artistas que tenemos a bordo en este momento, y así pueden conocer un poco más de cerca qué es lo que estamos haciendo desde la perspectiva de las diferentes personas que están participando en esta expedición. Estamos cercanos a terminar este segundo transecto y hemos podido observar varios octocorales, varios pepinos de mar, estrellas de mar, crinoideos. So we are just about to finish this second transect. So it's just when we hit the middle of the SuBastian or the end?
Yeah, just in the middle, yeah.
Okay. Like there?
Yeah.
Okay, yeah, that's it. Thank you, Maya.
If we do any more of these with this steep, we should probably try to do them all going uphill. We can do a lot better. It's easier because we're kind of going blind.
Yeah, that's right.
Hitting big rocks and
Yeah,
stuff.
yeah, you're right. Okay, so maybe for the next ones, what we can do is like have a first overview of the place, and then we can decide if one is going to be like in the steep, then maybe we can start with that one and end with the backwards on the flat part of the.
Yeah, sounds good.
Okay.
So the
So,
next location, we don't know yet. We just probably tell them. But,
you have the marker or the grain point of the next
I
one?
just put those two markers in to give us an indication of the first.
Okay.
Sort of where we were, 50 meters and 50 meters.
Yeah.
But I mean, do you want to start another one from here, or do you want to start?
No,
further around,
actually, we've been told that we should start the other one next to the venting site, but just
So the
let
venting
me.
site, I believe, is waypoint 1.
Okay, just let me check.
So we've wrapped up those two transects, and we're currently headed to the venting site, which we visited early in this dive and left some experiments. And it sounds like perhaps a couple more transects from there.
Acabamos de finalizar el segundo transecto y estamos en este momento desplazándonos hacia el sitio con flujos de agua caliente para poder realizar otros transectos en ese sitio. Estamos nada más terminando de confirmar con los cojefes de la investigación de la expedición para corroborar que efectivamente no tenemos que realizar más transectos en esta área.
Go mark that 50 meters and we'll start with that side. Come back.
Please, yeah. If we should move to the venting side, or if they want us to have another on this
Unless they want
side.
to go from waypoint up to the north or
We
something.
just finished the first two
Yeah, that
transects.
looks even steeper.
Thank you, Mario.
Yeah, at least we'd be going the right way if that's the way they want to go.
Yeah.
Okay. That's because they kind of changed the plans. At the beginning, they were going to be like 100-meter transect, and now apparently they are like 250 meters. So I just want to double check if the plan still sticks or have changed. Mientras esperamos confirmación para realizar los otros dos transectos, continuamos desplazándonos lentamente en este sector. Podemos ver varias esponjas de vidrio de gran tamaño, algunas con un crecimiento semicostroso laminar.
What do you look for, that little box? Oh, yeah. I think that I'm still almost passing on that line. Line. Which was off to the left. Oh, there you go.
Pueden ver en la pantalla en este momento varias de los experimentos que dejamos al inicio de este experimento. En la caja grande tenemos lo que se conoce como un osmosampler, que básicamente lo que hace es recolectar volúmenes determinados de agua por periodos bastante prolongados Las cuerdas amarillas son también las marcas de los diferentes experimentos de asentamiento que se dejaron para ver si hay asentamiento de comunidades microbianas o bacterianas durante el periodo que estén acá en el fondo. Y pueden observar también una bolsa con cubos de madera que dejamos igual para ver si se asocia fauna a este sustrato durante el tiempo que esté acá en esta zona. Precisamente todos estos experimentos y estos instrumentos de medición se dejaron en este sitio porque es donde hay emanaciones de agua caliente y donde están los pulpos asociados. So yeah, we are moving to the venting area, and then we are doing pretty much the same, one up and one down, 50 meters each.
Yeah, so from here straight north, or
Is it possible to take the turn?
To make like a whole turn?
No, I said to take the turn and then go up to the venting areas, that's what I was saying.
I don't know.
so is this is the venting area? correct?
Yeah.
So are we coming from the south, coming up to this point, or are we going from here up the hill? Because it all seems to be going
Yeah. Where is he? Caballito?
He's in the,
Just tell him please to come. Yeah, I know that meeting is something different.
like we can come
Yeah.
up into the to the east.
Yeah.
And come up diagonally if you like.
And then coming back to the west on the way down? Or
I mean, yeah, can. Do they have to be directly after each other, or can we do both?
No,
and
I
then
think-
come back
I
to the start
think-
and go back up again.
I think they could be just like in the same shape, like a V shape. That's what he told me, but I'm not sure.
Just you're gonna get better sort of results if we're always going uphill. So if
Yeah.
we could pick 2 points and go 1, 2.
Yeah, just like make them parallel
Yeah,
transects, you mean?
Yeah.
It could still be a V, but
Yeah.
as long as we're going this way
Yeah.
and then come back.
Come
and
back
then go
until the
that way.
starting point and then going to the other
Yeah,
way.
because you're gonna see better
Yeah.
because when we're reversing down the hill,
Yeah, yeah,
you know you can't see what's behind you.
yeah,
kind
yeah,
of
yeah,
thing.
yeah, exactly.
It's pretty
Yeah.
rocky and steep.
Yeah. Well, if it's possible to do it that way, just like finish the transect and then coming back to the beginning and then move
Yeah.
parallel to start the
That would be
next one.
better.
So,
That'd be better for us.
so just want to make sure because there are two options. Like we can make the transects parallel one to each other, or because in the previous one they were like in a V shape, so we have to actually did the second transect backwards because otherwise it was too complicated to keep the angle of the camera.
so, sorry, you came down and you came up?
First and the other one we came up and then we came down backwards.
Ah, okay, yeah, no, sorry, you
Yeah.
always have to go down slope and then come up.
Okay.
That's fine.
Yeah.
So did you transect over this spot yet?
No, we
But
just
this
up
last line here, those 2 markers is where we came down from. We came down from that north one there.
Yeah.
So we started somewhere
This line
where the
is-
snail trail is.
So it's just south and west of this venting site. And so now we've come back here, we're waiting for our next transect.
So you've done 2 transects,
here. 250 transects.
but one up and one down?
Yeah.
Okay, so, and none of them came over this spot?
No, this
Okay.
is just like the new second spot where we are aiming to do the next 2 transects.
The first one was this one. So
Yeah.
Yeah, okay.
there,
this is-
and then here.
Yeah, so the second one doesn't really count as a transect. So then let's just go down slope from here. It's hard to tell which direction that is on this moving map.
It would be this way.
Yeah.
South.
Yeah, so
and
basically what
east.
you try to do going down slope, we'll actually try to do going up slope. So you could go past that same marker to the
So we want to
southwest.
finish here, is that correct?
We want to go over this to the summit.
Okay. So if we just go straight south from here, 25 meters, and then 25 meters above this point, and that'll get it right in the middle.
Sure, that sounds great. Yeah.
The little white fish that you all were
Yeah.
eyeballing yesterday. One was down here, just at the bottom, off the bottom of the screen. There's one swimming around.
Okay, well, we'll come back to that
Okay.
after this.
I don't know how urgent it was for anyone. So.
Thanks for pointing it out.
Yeah, it's this little guy right there. There's your one.
Okay. We saw it at the Dorado, not here, but. That's
Yeah. I mean,
Oh,
it could
God,
be a different
can you take a highlight of that image, because this just shows how tiny, like it's a needle in a haystack finding this.
Yeah.
A little bit closer if you want an overview.
Yeah. Yeah, because each one of those octopus is like, what, that big?
Yeah.
So that feature is smaller than this room.
You'd want to stumble across.
Yeah, that we like found.
Yeah, that's right.
On our very first dive here.
Estamos confirmando cuál va a ser la posición de los próximos transectos y en este momento tomando una fotografía porque como pueden observar la zona o el área donde se encuentran estos pulpos en realidad es bastante pequeña, como acaba de indicar Beth Orkut, una de las jefas de la expedición. Haber encontrado este sitio con los pulpos en este afloramiento rocoso fue casi como encontrar una aguja en un pajal. Realmente es un área bastante pequeña en comparación a lo que pudimos observar en el buceo de ayer en el afloramiento El Dorado. So right now we are just moving and positioning the ROV in order to start the next two transects. And as you could tell from the previous overview, the area occupied by the octopuses in this unnamed outcrop is really small in comparison with the outcrop El Dorado that we were just diving yesterday.
So do you want us to kind of follow the face and go up, or do you want us just to keep heading, see how it's like at an angle?
Yeah,
No. We'd kind of be getting half of it, or we could turn into it slightly and sort of.
I think they want it straight.
Yeah.
Because they're trying to keep the amount of the face equal, so it's obviously wider than it is. If you're going sideways, it would be narrower. You know what I mean?
Yeah.
So they're trying to just keep it the same. Unfortunately, the slope is going to give you more surface anyways. So it's as best we can do, I guess.
Unless we move.
Yeah, unless we did it at a different angle, but she
Yeah,
said
just
north,
move
south,
all the way around and then come back up.
And then come back and then start the next one. Yeah. So yeah, I think we can just do it as Carl said, is the best way to have like a wider angle or picture of the transect, right? If we start this and not on the side, that's what you say, right?
So this will be the view basically that we're given all the way up. See how it's like?
Yeah, it's like
rather than having
like
if we were coming up the slope.
Yeah.
Straight at it, filling up your whole
picture. But if we
through that point, you would just go in a straight line coming up the hill.
But if we do it like in this direction, we are not going to hit the venting place, or are we?
We can move lateral along so that we will cross through it if you want. We would change the angle. But we could start on this head and move along past probably where our green marker is there and come all the way up.
Okay,
it's
so
pretty much going to be between the two markers that we did.
Yeah. So it will be possible just like to start it somewhere like here and do it this way and then do it like from here to here, or it's.
Yeah.
I mean, because if we are actually aiming to have something around here, yeah.
It's gonna do this again though. See, that's the peak. We're gonna be going over the peak and going downhill. The problem is this face is so irregular.
Yeah.
Trying to get a regular, consistent photo of video is. But we can try this, see how well it goes.
Okay. Okay, let's do that then. Based on that, and then we can decide for the second transit. And if not, then we just like try to repeat it and have like a third one. Yeah. Okay. Thank you.
I'm gonna clear your snow trails. Cheers.
Okay. So good to go.
Down, come up a little bit, down a little bit.
Wait. Can I start? No.
Yeah. So that's the other problem. Like we're doing 50 meters.
Yeah.
Not flat plane though, but the face is like this.
Yeah.
So you're actually transecting way longer.
Yeah,
than
it's
50
more
meters.
than yeah.
But that's the best we could do.
Okay. Let's give it a try then. If not, then we can just
so we'll
do it another
go from
one.
here.
Yeah. Okay. So should we start it now?
Yeah.
Okay. Yeah, we can start it now, Milo. Thanks. Vamos a comenzar en este momento el otro transecto, pero como pueden ver aquí nos encontramos en una superficie que no es completamente plana, es bastante irregular y además tiene una pendiente bastante alta. Entonces, realmente eso dificulta un poco la estimación porque los 50 metros no van a ser los mismos que si fuera una superficie completamente plana. Así que vamos a hacer el transecto y cuando lleguemos al punto final evaluamos si el segundo lo queremos hacer en la misma posición, en el mismo ángulo o si queremos cambiarnos a un ángulo diferente. Nosotros acá en el cuarto de control tenemos, como les hemos mencionado anteriormente, muchísimas pantallas con todas las diferentes cámaras que tiene SuBastian, además con todos los instrumentos, con la lectura de profundidad de los sensores que están en el submarino y también con varios mapas batimétricos que nos permiten ver la posición tanto de SuBastian como del barco. Entonces, los pilotos lo que hacen en estos casos para poder realizar los transectos es marcar un punto de inicio, un punto de final y utilizan una de estas pantallas como referencia para ir moviendo el submarino lo más cercano hacia la línea que se marcó con el transecto. Así es como logran mantener la posición lo más recta posible para lograr estos transectos lineales de 50 metros. Y como pueden ver, ahorita estamos justo sobre el sitio donde se identificó la emanación de aguas más calientes y que tiene la asociación de estos pulpos. El transecto lo estamos realizando en este momento a unos 2.800 metros de profundidad, tratando de mantener una altitud constante con respecto al fondo marino, pero cuando el sustrato, la geología es tan irregular, a veces se dificulta mantener la altitud exactamente igual en todos los puntos. Nos acercamos al final del transecto y cuando terminemos este transecto lo que vamos a hacer es dar una vuelta en U probablemente para poder colocarnos nuevamente en la base y poder realizar el segundo transecto de frente y no hacia atrás como tuvimos que hacer el segundo transecto de la vez anterior. So,
Yeah.
it's there? Okay, yeah, it's there, Myla. Thank you. Yeah, and I also see your point about like keeping the altitude that is, we were about 2 point something meters, right? Because it's not possible to get closer to the bottom because it's very uneven.
Jagged, some bits
Yeah.
are
The
from
front,
higher.
Yeah,
the measurement is from the center of the RV.
yeah,
So the front is actually closer, so we have to understand that and actually be a little bit higher
Yeah.
to maintain your view that you're wanting. So basically, you're wanting the camera to maintain 1 meter,
Yeah.
not the RV.
Not the
So that's
ROV.
what we're trying to do.
We're,
Okay.
we're looking at this, and if the front looks like it's going to catch on a rock, we
Yeah.
need to come up a little bit, but
Yeah.
then you might be 2 meters off
Yeah.
in the middle,
yeah, exactly. Yeah,
trying to monitor
yeah, yeah.
when it's ragged like this. Is,
Yeah. Okay, so should we go back to the or close to the point where we start so we can just move parallel to that transect and do a second one?
So we want to do another one.
Yeah, somewhere like something like that. Yeah,
How far away?
from the venting side. So
this one wasn't as steep, and if we sort of adjust our heading, we can match the hill a little bit better. We just pivoted here and came straight back to there. This wasn't as bad as that last one.
Yeah.
We could get away with trying to do this,
Yeah.
and then it would
Yeah.
would face more into the slope, I think, because as we came up, it sort of turned on us a little bit. So we could just reverse from here, head for.
So how's that look? You want that further away from each other, or you said parallel, right?
try to do it parallel. Yeah, is the yellow point the venting side or
Yes.
is just like the okay?
Yeah. So you want to do
So
parallel, or we can come from this exact point and go back and make your V,
yeah, but
and then
it,
that will turn us more into the slope and match the slope a little bit.
You can slide it backwards. If you start here, right?
what do you think?
So we finished?
We finished the first one.
As
The thing is
steep,
because
but
the slope
it's
is
easier
kind
to
of
come up,
steep,
but
then
yeah,
sometimes
it is.
they actually have to go a little bit higher. So it's not possible to keep always like the 1 meter off from the bottom, right? So what we are considering is to do it like parallel instead of doing in a V shape. That way we can try to keep more or less the same slope along the transect.
Okay, you say this is the first one, I thought there was one done on Jorge's shift.
There was one V1 because he told me that instead of doing like 100 meter, we were going to do 250.
Yeah, so
Yeah.
if he did one and you did one, then we're done.
No, he did 250, and now he told me to do 250 more. So he said to do 450 transects instead of doing two.
No, it was just two 50-meter transects.
Okay, so that means that now we have one extra 50-meter transect.
Yeah, that's fine.
That's fine.
Yeah.
Okay.
Yeah, because we just wanted one up and then another up.
Okay.
So as long as we have that, then we're done.
Okay.
And the reason, because we need to start moving towards waypoint 2.
Yeah.
So.
Okay, then, and this just cross like
Yeah.
on top of the bending side with all the octopus. So.
Okay.
Okay.
Yeah.
Good. Then should we start moving to the waypoint 2?
Yeah, and we'll want to just fly along the bottom and see where it looks like there's sediment, and anywhere you see that, we'll just try to poke it with this caliber.
Okay.
And
No. Just
no, the transect was just up here.
Okay. Okay.
So waypoint 2 is the south one.
Yeah, it's about 400 meters away, so hopefully we find sediment before we get there.
So how are we going to fly that one out? I suppose that's the move when we start getting closer.
All right, so it sounds like they're going to move on to our next waypoint, but along the way, we're going to be looking for areas that we could do a heat flow probe.
So updated waypoint.
Yeah. So we are going to finish the transects with this last one, and we are now heading to waypoint 2. And on our way, we are going to try to look for some of the target species that we have for this dive. And if we cross with some sediment bottoms, then we will try with the poking stick just to see if the sediment is deep enough to do some heat flow measurements or even sample some push cores. Vamos ahora a desplazarnos hacia el próximo punto que tenemos marcado en este buceo. Ya no vamos a realizar más transectos y en el camino hacia el próximo punto vamos a tratar de buscar algunas de las especies objetivos que tenemos para colectar en este buceo. De igual forma, si nos encontramos con fondos arenosos, vamos a utilizar el Excalibur para medir la profundidad, y en el caso en el que tengamos suficiente sedimento, entonces procederíamos a realizar mediciones de flujo térmico y también a recolectar núcleos de sedimento. So do we have to wait for the ship, or is the ship actually waiting for us?
Ship's going.
Okay.
It takes a little while to.
Yeah.
It's very slow to get going.
So this is the type of views you get when you're facing down the hill.
Yeah.
Yeah, see we are very close to the bottom still, but because
Okay.
it's going down.
Yeah. Les recordamos que en estas operaciones de desplazamiento hay una coordinación bastante cercana con el puente, que es básicamente desde donde se navega el barco, porque tienen que desplazarse el submarino y el barco de forma simultánea. Entonces, a veces el barco tiene que esperar al submarino y a veces es de la otra manera, que el submarino tiene que esperar al barco. Pero en este momento ya nos estamos desplazando de manera paralela, tanto el barco como el submarino, hacia el punto de muestreo 2.
Turning a little bit. Okay. See if we can get an actual visual on it.
Just slow your forward maybe and just focus on getting out.
un dato curioso sobre esta embarcación de investigación es que está inspirada en el cuento de la historia sin fin. Por eso es que el barco se llama Falcor y el submarino se llama SuBastian, porque también está basado en uno de los personajes principales de la embarcación, perdón, del cuento.
Might be okay just flying it backwards, but because we don't have to stay so low, maybe it'll be more comfortable. I don't know.
Yeah, I'll spin it around.
Actually, it's starting to come in. I think you're about to get better now.
Okay. Oh, yeah. Yeah, just a little bit flying a little bit.
En este proceso de movilización de un punto hacia otro, los pilotos tienen que coordinar bastante bien, asegurarse que mantenemos el trayecto deseado, pero además que se encuentran a una profundidad donde todavía pueden maniobrar de manera segura el submarino sin tener problemas de chocar o rozar alguna de las rocas del fondo submarino. Is it possible to go a little bit closer from the bottom, or is to?
Well, if you look on this camera here, it's how up close we actually are at the bottom.
Okay.
You see the shadows.
Yeah.
So like the back of the ROV is pretty
It's
much
already very close to the upper.
very close, and it's just because it's coming down like this.
Yeah.
That's all we can see. I mean, we can turn around and reverse.
Yeah, the discussion that's being had right now and why we had to run a transect in reverse earlier is on these steep slopes. Of course, the ROV is a little longer than you ideally want to keep the camera both close to the bottom and also to have the ROV not hit the bottom. So although the view there looked like we were actually quite high up in the water, we have another camera here that showed we were actually very close to the bottom with regards to the rear of the vehicle. So just one of those things that our pilots has to keep in mind as they're doing these sorts of maneuvers.
En el video ahorita que estábamos descendiendo, parecía que estábamos en realidad navegando bastante por encima del fondo. Lo que sucede es que el submarino de hecho es bastante largo, o por lo menos más de lo que a veces se requiere para maniobrar. Entonces, como les comentaba, el submarino tiene cámaras en diferentes posiciones y si bien es cierto, la cámara frontal nos indicaba de que estábamos bastante alejados del fondo, en la cámara que se encuentra en la parte trasera del submarino podíamos observar que en realidad esa sección se encontraba bastante cercana del fondo. Así que cuando el submarino se está desplazando en una pendiente que es muy inclinada, los pilotos tienen que maniobrar con mucho cuidado para evitar que uno de los costados o de las secciones del submarino tenga algún roce con el fondo.
So there you can see in the heat flow probe camera, we are skimming just over the bottom.
Ahorita tienen en pantalla justo la cámara que les mencionaba que se encuentra ubicada en la parte trasera del submarino y ahí pueden ver o apreciar el detalle de qué tan cerca se encuentra en realidad la parte trasera del fondo y cómo hay una diferencia con respecto a la distancia de la cámara que se encuentra ubicada en el frente del submarino. Thanks for switching cameras, Alex. Acá vemos una anémona bastante grande. Can we turn the lasers on, please? So you can, as a reference. Thank you. Okay. Acá con los láser podemos hacer una estimación. Esta anémona parece ser que tiene un diámetro aproximado de unos 25-30 centímetros. Es una anémona bastante grande que se encuentra en este fondo de este monte sin nombre que estamos explorando en este momento. That's definitely such a big anemone. With the laser, we could estimate the diameter about 20 or 30 centimeters.
Couple crustaceans hanging out.
Yeah, just on the base of the anemone. These two that we can spot, but there could be more. Yeah. I think those are squat lobsters or something similar, right? And that's just like a scale worm appearing in the picture. Esto que están viendo en este momento son algunos crustáceos que viven en asociación con la anémona y un gusano marino que apareció nadando en la imagen. So, if we spot any of the clear sea cucumbers, that's a target species. Also the crinoids, or we are still missing black corals and one of the swiftia corals, which are like the yellowish orange octocorals. Continuamos nuestro desplazamiento hacia el punto 2 y vamos ahora a tratar de ver si encontramos algunas de las especies objetivo. Conforme ha ido avanzando la expedición y hemos logrado recolectar diferentes especímenes, básicamente llevamos una lista donde vamos tachando qué tenemos y qué nos falta todavía por recolectar. Así que vamos a mantener nuestros ojos abiertos para ver si podemos ubicar algunos de estos pepinos de mar de color transparente que todavía tenemos que recolectar, así como algunos corales negros, octocorales y crinoideos, que los crinoideos son también parientes de los pepinos y de las estrellas de mar. Wait, is that the airborne ass fish or whatever the name was of that? Hace unos días vimos un pez con un nombre común bastante inusual. Creímos que este podía ser el mismo, pero no. Y de hecho hacia la derecha del pez había un erizo de mar. Cuando estamos desplazándonos en estos fondos es bastante fácil distraerse con las diferentes cosas, los diferentes organismos que aparecen, así que los pilotos se encargan de tratar de mantenernos en el rumbo mientras nosotros vamos observando los diferentes organismos que se ven. Y en el momento en el que vemos algo que puede parecerse a una de las especies objetivos, entonces nos detenemos. No, but I think this is the ones that we already have. Yeah. Yeah, we are aiming for the more transparent ones, like this. Yeah, they're really kind of whitish, clear sea cucumbers. So who's next? Rob? And who's leading the live? Rachel?
Gus.
Ross? Okay, then I'm just going to wait for him. Como pueden ver, usualmente en estos fondos que son un poco más blandos, hay más estrellas quebradizas también, pero usualmente son buenos lugares para encontrar los pepinos de mar, que es una de las especies objetivos que tenemos en este momento. Y en este momento estamos teniendo nuevamente el relevo de pilotos. Rachel, do you think you should try with the Excalibur here? Or not? Or is probably too rocky?
Maybe a little bit further out.
Yeah? Okay.
But thank you. Soon.
Okay. Para algunos de los muestreos que ocupamos necesitamos fondos bastante sedimentosos, pero aquí todavía se encuentran bastantes rocas, así que vamos a continuar. Voy a darle paso ahora a mi colega Gustavo Ramírez, quien va a continuar con ustedes durante la próxima hora. Y les agradecemos por mantenerse en sintonía y permitirnos llevarles un poco de las exploraciones de aguas profundas del Pacífico costarricense. Pura vida y muchas gracias por mantenerse en sintonía. So I'm going to hand it over now to my colleague Gustavo Ramirez, who is going to stay with you over the next hour. So thanks a lot for staying tuned and joining us on this Odyssey Expedition. There is a list of target species preparing in case you find something.
Okay. And what else? It's venting, right?
It's just look for the venting.
Yeah, it's not an official transect, right?
No. We
around.
just finished like all the official transects. We just did it here in this previous area. So right now it's just like exactly whatever we find on the way to head with two. Yeah, exactly. Unless think unless we is one of those, or even if we find like the Swiftia corals or the crinoids, I think that is also very interesting in getting to crinoids. Otherwise, just like continue getting through this area. Son estas como estrellas, they're brittle stars. They're like feather stars, actually.
Feather stars, okay.
Because they're like feathers, but stars.
Got it.
Yeah.
I'll text everybody. Please.
Yeah, for sure. Yeah, that's it.
Okay. Thank you.
Sure. Thanks, guys.
All right. Yeah, so we have colors on. Good afternoon, everyone back home. My name is Gustavo Ramirez. I'm an assistant professor of microbial ecology and computational biology at the California State University in Los Angeles. I'm fortunate to find myself about 150 kilometers off of the coast of Costa Rica in Costa Rican waters on board the Falcor research vessel. This is an expedition that I've joined called Octopus Odyssey, funded by the Schmidt Ocean Institute. And we are here at a seamount at a seamount hunting ground at 3,000 meters beneath our feet. We are on top, riding the waves and sending our friend SuBastian, a remotely operated vehicle, 3,000 meters down to explore seamounts and outcrops, which are seafloor features that are remnants of previous volcanism in the area. And what we're going after here is places on these seamounts where warm fluids emerge from the crack in the rocks and appear to aggregate female brooding octopus, deep sea octopus. So hence the name of the expedition. And I'll be narrating what we're seeing here live from the ROV control room for the next hour. Yeah. Okay. The ROV pilots are informing me that we are taking some time to check our gauges. So these are SuBastian gauges. Back home, they see that. Yeah. Okay. All right. Yeah. Oh, that's just main The images that you guys may be seeing back home are coming from our secondary camera. Our primary camera is currently being used to look at gauges to help navigation of SuBastian. We will switch camera view shortly. Getting a couple of good close-ups of just amazing benthic life. We are on our way to a second waypoint during this dive. having achieved most of our major objectives already, we will be on the search here for unsedimented sites, perhaps just outside of the field of these high concentrations of rocks that we're seeing on the seafloor here, where we will aim to collect push cores and take some Niskin bottle samples.
Looks a bit more sandy here.
Almost good enough for cores, yeah, right? How far away are we from the waypoint? Oh, wait, we're about 2/3 of the way there, right?
Yeah.
And it's dropping in elevation, right? Lower.
Yeah, it's a lot flatter. Yeah, we were in the steps.
Okay, here? Okay.
Like you look, it's just to see.
Yeah.
Yeah.
Caliber?
Yeah.
Before we get to okay. Before we get to check the sediment depth here.
So the pilots are going to touch down here and give a little test probe using Excalibur, which is just a rod of metal we have. But we want to see if this sediment is soft enough to potentially do a heat flow test here. And the heat flow probe is much more delicate. So that's why we test before with Excalibur. And then if that looks like it's going to be good, we'll deploy the heat flow probe down into the sediment.
In order for us to truly understand the fluid flow of this entire ecosystem here, it is very important that we get heat flow measurements. A lot of this data collection is being led by Professor Rachel Lauer and her doctoral student, Mr. Rob Perrin from the University of Calgary, that are here in the control room joining us also. Again, they are physicists and modelers that are using a computer that's fed by data, temperature data collected from the sediments around this seamount, this complex of seamounts. They're able to better constrain what are the possible rates of flow and vectors of movement of massive amounts of water that must be flowing underneath the sediments here for that eventually lead to the emergent properties of generating entire ecosystems of brooding octopus females that we're all here to see and love. So again, our ROV arm, SuBastian's ROV arm, is gripping this metal stick that we call Excalibur. There's no instrumentation. The stick is simply made out of metal and it's marked with known depths, and it allows us to it allows us to test whether or not the sediment is soft enough and deep enough to insert the sensitive heat probe that we also have on the ROV with us, but that is now currently stowed away. I just call it fish.
Great, Darby.
I used to just orange.
Great, Darby.
That's not orange, that's
Great, Darby.
it's just a fish.
All right. So we gave it a little poke, and it seems like that's actually just hard rock under a very thin layer of sediment here. Yeah, we're gonna do another one just to check on it.
Yeah, if you could just come and all stop on that. Just now, just setting up myself.
I'm gonna give a firmer grip on the Excalibur here and see how it goes. A little better. Yeah. Seemed kind of stop and go.
Again, we're basically doing a sediment depth test here.
Yeah.
Can we do it one more time, just to?
Yeah.
Is that stop and go from like hitting little rocks on the way down? Yeah.
That's not too bad.
That one's not bad. Okay.
Start against it up, then pushes out of the.
Yeah. What do you think? You want to go a little bit further, or?
Yeah, let's go a little bit further. Thank you.
Okay. 2/3 of the way there, and dropping the slope.
Yeah, associating it against something.
I guess right after you guys see your temperature measure, I'll get my push button.
Yeah. And trigger listing model. Okay. There's no.
I was hoping we're getting more than one.
Yeah, it says that China allows continued use.
Okay. We can try here, I think.
You want to try it one more time?
Yeah.
Just come down nice.
Thank you. So once I set this up,
I'm not sure.
And after navigating a few meters southeast of the last place where we checked the sediment consistency, we will try that again. So this is our test site number 2. Again, where you're seeing there is simply a metal rod with tape markings separated. Each marking is separated by 10 centimeters or so. And what the ROV pilots are doing now is inserting this metal rod that we affectionately call Excalibur into the sediment. This should let us know if there's bedrock underneath.
But that's much deeper than what that goes in.
Yeah.
Hmm.
Yeah.
Yeah, so this is basically confirming that there isn't a layer of rock that's potentially shallow and that could interfere with our heat flow measurements. And all the action that you see on your screen is based on skillful manipulation, remote manipulation of this SuBastian robotic arm by our 2 pilot team in the control room now. J-Rod is the pilot handling this operation, skillfully handling this operation from a really cool looking joystick just to the right of me. Bueno, puedo dar un resumen de la acción que seguimos viviendo aquí en el lecho marino. Lo que están viendo en su pantalla es la introducción de un tipo de varilla térmica que nos da indicaciones que puede medir la temperatura dentro del lecho marino. Pueden ver que la varilla se está introduciendo. Eso es un instrumento térmico. Y bueno, antes de introducir el instrumento térmico, que es lo que ven en la cámara blanco y negro en su pantalla, hicimos pruebas con con otra varilla que no es instrumento, simplemente una varilla con el brazo del robot SuBastian. Esa prueba nos dio confianza o nos dio certeza de que no hay piedras que están muy cerca de la superficie del lecho marino y solamente después de haber hecho las primeras pruebas iniciales cuando es cuando introducimos el instrumento, que es lo que se veía o lo que se sigue viendo a mano izquierda superior en la pantalla. Bueno, bienvenidos a todos. Me llamo Gustavo Ramírez. Soy profesor de Ecología Microbiana en el Cal State University en Los Ángeles, California. Nos encontramos a bordo del buque de investigación Falcor 2, justo a más o menos 150 kilómetros de la costa de Costa Rica, en el Pacífico. Soy parte de una expedición llamada el Octopus Odyssey o la Odisea del Pulpo, que llevamos 2 semanas, más de 2 semanas ya en mar abierto, investigando montañas submarinas donde se han recientemente descubierto comunidades de pulpos de hembras, pulpos hembras que buscan lugares en montañas submarinas llenas de piedra, donde en algunas piedras emanen fluidos hidrotérmicos. Estos fluidos hidrotérmicos son aguas un poco más caliente que el frío de las aguas frías que están en el lecho marino, y las hembras de esta especie de pulpo profundo buscan estos lugares donde el agua emane para dejar sus huevecillos. Y bueno, se quedan ahí cuidando los huevecillos años, no sabemos exactamente cuánto tiempo, pero lo que sí sabemos es que es importantísimo para estas hembras de pulpos marinos buscar lugares en las montañas, en el lecho marino, donde hay fluidos hidrotérmicos saliendo al océano. Solamente ahí se ven los huevecillos de pulpo. Y bueno, lo que estamos haciendo aquí, tomando temperaturas del lecho marino, es tratar de entender un poco más la física detrás de la oceanografía física detrás de los procesos que resultan en estos fluidos hidrotérmicos en las montañas. Otro punto que diré aquí es que el proceso de la circulación hidrotérmica del agua del océano, de una montaña submarina a otra, básicamente filtra toda el agua de todos los océanos del mundo con una periodicidad de una vez cada 300,000 años. O sea que es un proceso importantísimo para llegar a un equilibrio químico global en todo el océano, que últimamente determina el equilibrio químico del planeta en la atmósfera y propiedades muy importantes planetarias como el estado de reducción de todo el planeta, y eso, bueno, tiene consecuencias gigantescas para la evolución de toda la vida. La vida en el lecho marino es extremadamente abundante. Aquí estamos viendo un ejemplo de un pequeño animal. Pero bueno, yo siendo microbiólogo, al ver cualquier parte de los sedimentos marinos, lo que veo yo con mi enfoque de microbiología son los miles de millones de microbios que existen por centímetro cuadrado en todos los sedimentos de todo el lecho marino globalmente. O sea que en la cámara vemos solamente un animal, pero bueno, por cada centímetro cuadrado millones de microbios que viven ahí también. Everywhere we focus our camera on the seafloor, we see signs of life. It's a remarkable property. What we're seeing now is a small crater there, perhaps a nascent coral in the back too. But I guess every time I look at any parcel of mud on the seafloor, as a microbiologist, what I see are the tens of millions of microbes that live in any given cubic centimeter of mud collected from anywhere in the world. So that is what I am seeing right now, despite having this charismatic little critter on the seafloor focus with our cameras. And that's of course the microbiologist in me. To give the audience here another quick recap, we have introduced a thermal probe into the sediment, and this thermal probe will inform us on the potential heat flow patterns and water movement patterns of this large amount of water. So must be moving from one seamount to another in this area. Again, this water movement is ultimately what dictates the emergent ecological property that was the motivation for this expedition. That is understanding octopus behavior better. What we do know about octopus behavior thus far is that the females preferentially select areas of hydrothermal venting to lay their egg clutches. And we don't know why that is. A couple of hypotheses are out there that try to explain this behavior. The simplest hypothesis would be that the hydrothermal venting brings with it advection or water movement that simply clears rocks. So it may be a spot that's selected by the females just because it is a guaranteed spot that will remain clear of the ever so slowly yet perpetual pelleting of marine snow that eventually turns into a sediment layer on top of rocks. So that is the first hypothesis that could potentially explain this behavior or bring light to this behavior that we're testing. Second hypothesis would be that perhaps the temperature of the fluids benefits the embryos to some degrees. So again, the jury's still out as to which one of these two hypotheses is more appropriate or correct. A third hypothesis, and one that I am very interested in, is that the females that the hydrothermal fluids where these embryos develop may carry with them special microbes that basically give the developing embryos a microbiome-based advantage. So that's, I guess, a sort of a natural probiotic. So that is something that I am definitely interested in and that I'd like to study further. But again, we don't know which one of the above reasons and perhaps other reasons may be driving the female octopus egg brooding behavior, but that is some of the primary reasons of why we set out to sea for a couple of weeks in this Octopus Odyssey Expedition. That is one of the main things that we want to explore.
That's the second time I've seen one of those. Shark tooth? That's the second time I've seen one of those little ball bearing looking things. But
What are we talking about? This right there?
Earth
Yeah,
mouse.
I don't know what that is. Oh, interesting.
I'm sure it's gelatinous. Think so? I think so. I have something that can touch it. Oh. You don't know what it is. No. We just don't know. These tiny snacks, it looks like from like cucumbers. It doesn't make that small.
Fecal pellets, right?
Yeah. Little worms or something. That almost looks like a clay.
So as we have to kind of wait here in place anyway, during the heat flow, we can just zoom in really close and focus on this little tiny plot in front of us. And that's where we really seem to find all these tiny little details, is when we have this kind of ability and also obligation to just stay in one spot.
Sometimes, yeah. All the questions. Yeah, the griddles are like flexed. Planks.
Just having a good look around this alien landscape while we wait for our heat probe measurement to be completed. Going in and out of focus there, but I mean, it's very interesting to see this the current and the marine snow that's constantly reaching the seafloor. How far do you think the light goes out? How far can we look at the edge of like 5 meters, 10 meters?
I would say definitely over 10 meters.
Over 10 meters.
Somewhere between, depending on how far we are to the bottom.
Yeah.
Like if we're up a little bit, I think it's probably
Further out,
Not
right?
like super in focus, but you're seeing 20.
Yeah.
Yeah. So actually, when we got that big siphonophore in Australia, it was 60-meter diameter. So,
Whoa.
yeah.
You capture all that?
Yeah. So and we were able to see it all in good light. And
Okay.
So we were getting out further than that.
That's impressive.
Yeah, so I mean, pretty much easily to say that this lighting area
Yeah.
would be 60-meter diameter.
Wow.
Well, the thing to keep in mind is the water's going to filter that light on the way out. And
Yeah.
It's going to filter it coming back to the camera. So as far as we can see, the light should be visible twice that distance.
Right.
That's a very good point, but I've never put this in my brain.
It's all full color, but they had to cover a distance.
Yeah, we put out, we have all the lights, we're down one light right now.
Yeah.
But with them all, we can put out 500,000 lumens.
Wow.
That's 4 of them are spotlights. Well, currently 3 of them are spotlights, and the rest are all floods.
It's weird to think that something can see us from twice as far away as we can actually see out.
Well, technically, these things are probably.
Well, yeah. That's all right, yeah.
Just
that
as-
thought's always in the back of my head.
Yeah, just discussing the workings of light underwater and discussing that how far away do our lights actually shine, and of course things that we can see in the light. The water is acting as a great filter for that light, both on the way to the object, and then the light bounces off that object and it has to make its way back to the camera. So if you were talking about how far away could a human see the lights on the ROV, it would be twice as far as we can see something using the lights with the ROV, because it's being filtered the same distance but not folded in half like when it bounces off an object. So you never know what's out there watching ROV SuBastian from afar. Oh, that's the other thing. They're going to hear us coming first. Yeah.
All right, we're all good.
Yeah. Pulling up the probe.
Professor Rachel Lauer has given us the green light to end the heat flow measurement.
Set fluid attracted. And where you want.
You get a missing here?
Yeah, I guess that's
Are we-
the instructions.
Are we also gonna be doing another heat flow probe somewhere else, like here in a bit?
Yes.
Time allows, yeah.
I just wanna know so I can just let go
Keep
of
the
this
Excalibur.
and then just go do your Niskins and then pick it back up.
Yeah.
Which
Actually, I
Niskins do you want? Looks like we have 4 and 5 triggered already?
Yeah.
Is that correct?
Yeah.
What works for you?
Just says Niskin sample, I think it, should I ask?
I guess they have different sizes.
So that's to,
Yeah, so we have 1 more 2.5 liter left
okay,
and 3 more 5 liters. So the last time they did 1 5 and 1 2.5.
let's do that then.
Yeah.
Yeah.
I think that she needed,
She what?
she needed water.
Yep, yeah, so one of each.
One of each. Yeah.
One of each, one of.
I think I might just get my push pusher too.
We're gonna do push push here?
Yeah, but I suppose it would be better to get the Niskins first, right?
Yeah.
Potentially disturb them.
Oh, yeah,
that sounds like.
Mm-hmm.
How often, so obviously you're interested in much smaller things in the push course, but how often are there like just worms cruising around in there? You can see?
Quite often, actually.
Quite often,
Yeah. Thank you. Yeah, especially with this very shallow sediment depths, 10 centimeters. Yeah, it's you get things burrowing pretty deeply.
Yeah.
Yeah, so
I know I've seen the push course. So obviously we can do push course with ROV SuBastian by actually using the manip to drop it in. But there are deployed push cores that fall down to the seafloor, slam these tubes down into the bottom, and then they come right back up. And I've seen those bring up like brittle stars and everything else. It just depends where they land. When we're sampling with ROV SuBastian, we can be very selective and say, well, there's a brittle star. Let's not stomp down right on that. But when you just throw something over the side of a ship, you never know where it's going to go down.
are you speaking about landers specifically?
Like a lander
Yeah.
core, yeah. They're cool to see. Like I like when there's cameras on them because it just goes, it hits, and then those cores slide down into the ground, and then it drops the weights and comes right up. And the little caps slap on the bottom of the tubes as they come out. There's some great footage of it.
Is that the iris opened up with possible?
Yeah.
I don't know. I'm gonna go for 3, is that okay?
That works.
Okay, so doing push course here,
Yes, please.
all of them?
Yeah, let's go ahead and do all 8.
Alright, so when we bring out the tray, or out the rail, it starts messing up the mud, we might have to pick up and reposition it, we can get them out, and then we can get them.
Yeah, that's nice.
Yeah. That was over there.
Yeah.
So everyone watching back home, we just triggered something called the Niskin bottle sample here. So on the side of the ROV, there's 6 large cylinders of 2 and 5 liter volumes that are open at both ends, at the top and at the bottom. When we want to sample a large quantity of water from a particular depth, we simply close the tops and bottoms of one bottle at a time. This closing the tops and bottoms will bring back 5 liters worth of water within that plastic cylinder all the way back up to the surface. So that's the last activity that you saw there, what we're doing now is collecting sediment push cores. So these are cylinders that are sealed at the top that basically stab the seafloor and perfect, that works. Yeah. So we're able to stab the seafloor with these tubes that are sealed at the top, and then simply pick them back up, creating a vacuum at the top, and that vacuum allows us to recover the sequence of sediments with relatively undisturbed seafloor all the way down to a depth of sediments that's equivalent to the length of the tube. We will collect a total of 8 push cores at this site. Once the push cores get back on deck here on Falcor later this evening, there'll be an army of sediment enthusiasts going after them. I am interested in the microbial metabolisms or the activities of the microbial communities that live in this mud. So a pretty standard test that I've been running on every push core collection is the extraction of, it involves the extraction of something called pore waters, which is simply the water that is trapped within the mud itself. That's supposed to be a different chemical signature than the water in the ocean just directly above the mud. Another one of my interests, of course, will be extracting nucleic acids like DNA and RNA from different layers of these muds collected with the push cores to generate DNA and RNA profiles that will then allow me to, number one, be able to identify the different microbial species that inhabit each one of these sediment layers. And number two, say something about their activities. How are they able to survive here? What are those microbes breathing? Do they breathe oxygen? Are they able to breathe nitrate? What are major nutrient-related activities that they engage in? Are they able to fix carbon, fix nitrogen? Do they cycle phosphorus? So all of these basic questions can quite easily be addressed now by the generation of something called metagenomes. So that is the sequencing of all the DNA from all the microbes that live in any given parcel of mud. Another important use for these push core sediment samples will be paleosedimentology. So there are specialists on board that can look at different depths of this mud in slide smears and identify tiny shelled organisms that can give us an idea of the history, the sedimentation history of this place at a very, very high level of resolution.
Painting while I was out. I just stepped out for a second.
No, I haven't yet. Go ahead. Yeah, go for it.
So one of our artists on board has actually made paint using some of the sediment that we've collected now, and is just doing an awesome painting that shows the structures you see on those microscope slides that are being prepped from the sediment. And that means that hypothetically, if you then looked at the painting under a microscope, you would see the same structures that the painting shows. But yeah, he brought along some oil and medium and mixed up some using some of the sediment on the ship. So very cool.
Yeah, there's definitely no shortage of inspiration when walking around Falcor as a scientist and a bit of an artist myself. I'm blown away by the quality of work that both of our artists at sea have been producing throughout our over 2 weeks at sea now. So
yeah,
it's
I think we've got a blog probably that'll talk about the art. And if folks want to check out those blogs, because we do have the teams that come on board for each expedition, we have them put together blogs. So if you go to schmidtocean.org, you can find this current expedition, Octopus Odyssey. And I think there's 2 blogs. I haven't looked today. There might be 3 up now, but there were at least 2. And they're just fun reads. They really go into it.
Just as a quick recap for the audience, we are exploring a previously unexplored seafloor feature that's east of a larger seafloor feature that's been putatively called Caballito. Some chuckles here. Yeah, none of these names are official. But I guess there's at least one mention of this larger feature in the literature that calls it this name, Caballito, or Little Horse. So on this feature, east of Caballito, we have confirmed at least one site of hydrothermal venting. And right along the venting, as we've seen in the nearby outcrop called El Dorado, we also observe brooding octopus females. So the entire point of our expedition is really to go on the search physically, geochemically, and microbiologically of this incredible octopus phenomenon or behavioral phenomenon, which is the females preferentially choosing sites of venting, shimmering, relatively warm fluids to lay their egg clutches.
Got a question about sharks. We haven't seen any this expedition, I don't think. Sometimes we'll see them during recovery on the ROV cameras up closer to the surface. There'll be something. Yeah, more up shallow, but we haven't seen any on this expedition yet, I don't think. Cat sharks, yeah, that would be a deeper one. 6 gills.
What's the normal
Need a shark expert.
Yeah. And then you do have deep water sharks, things like sleeper sharks, the Greenland sharks. Yeah, they are there, but on this expedition, not really. We've actually mentioned a couple times when we're looking at these octopus nurseries, I mean, sharks aside, just there doesn't seem to be a lot of predators of the adults. Obviously, there's tons of predators of the eggs. Yeah, just waiting. But
how long did it take for an octopus mother to step away and have the shrimp nibble away at the?
Yeah,
2 minutes, right?
It was like
yeah,
moments.
please.
Yeah. Now, a lot of people don't think skates are as cool as sharks, but I mean, it's just a flat shark, or a shark is a round skate, right? So we did find a skate nursery during this expedition, and that was really fascinating. Just piles of skate eggs up on top of another outcrop.
Skates are indeed cartilaginous fish, right? Yeah.
Yeah, skates, rays, sharks.
Okay.
Good. Yeah, we're on our way to waypoint 2.
Okay.
And we did Excalibur twice, just to check the sediment depth and consistency and all that. Second time, Rachel and Rob were happy, so we took the heat probe measurement.
Okay.
After the heat probe, we closed the Niskin, and we did 2 hours.
We have two Niskin balls.
This is going in number 8.
Okay.
Should be in the log. So, anyway, so 2 Niskins, and then we moved on to the 8 sediment cores. We just picked up the first one. I don't know what number it is, but I mean, it's holster number, whatever. What's that?
Okay, igual sacamos todos. Ajá.
Yeah. So, yeah, if we want to take over, go for it. I think we're just working the sediments back in. What else do we need to do? We're on the lookout for brittle sites. And then we're also on the lookout for these 3.
They want it.
Yeah, but above everything, we're on the lookout for hydrothermal venting. So, if this guy's next to venting comes first.
Yeah.
Yeah, thermal measurements, whatever. But if there's no venting, that's really important.
So normally, if we go to waypoint 2,
yeah,
there will be rocks too.
I don't know.
So there is a little plug or bung down at the bottom of these. And so when the pilots are pushing down on the cores like that, they're trying to make sure that it's pressed down onto that so that we don't just lose sediment out the bottom.
Yeah, as long as these numbers match.
It is something to note, though, about the depth. We had a question about the depth, and of course you can view that in the lower left. But actually, now that I'm looking at that, our depth currently is 2.9 kilometers. And I want to say when we were up top, we were at like 2.82. So we've come down a little ways. 1/10 of a kilometer. I can pull up the map while we're pulling these cores up. All right. So we started up at waypoint 1 up top there. And I don't think we actually have waypoint 2 on this map, but you can see we have come down not quite onto the flattest area yet, but certainly much flatter than the slope we were at.
Is that okay going in reverse order?
Yeah, yeah, we're just making sure we're.
You just gotta document it, that's all.
So-
Yeah.
Let's change the. Well, these, yeah, it's. Okay. This is the order that in the ground.
You just do that, it breaks the vacuum around it. So if you just go straight up, you're fighting on the vacuum that you put in there, as opposed to using the vacuum to just keep the sample. So you don't want to fight that.
Oh, it's 6. Oh, it's 6.
It is. You'll see if you do that, see how the top water is clear?
Yeah.
Your top water is coming up and it's muddy, then that means that your vacuum got full. Isn't always an interval, but that's not accurate. Cleaner the top water is better, and you should always have water.
One of the major microbiological goals of this expedition is to really understand what microbes live on both living and non-living parts of this ecosystems. So there we have specialists on board that are doing dissections on specimens of animals that we've collected at these sites that are looking at the microbiome of those animals in different parts of the exterior and gastrointestinal tract. We have other members of our microbiology group here that are going to look at the microbiology of the rocks. So there's been different collections of rocks here, basalts, more carbonate-looking rocks too, and we're taking that back to the lab to also understand the microbial communities that are on the rocks. Clearly, we have been collecting fluids for a long time too, and there will be microbiological analysis, independent microbiological analysis of the microbes that live in the pristine fluids collected at these high fluid flow venting sites. So we want to know what microbes live in the background seawater that's cold. We want to know what microbes emerge into this ecosystem in the warm hydrothermal fluids that come up through the cracks where the octopuses hang out. We want to know the microbes that are on the rocks. We want to know the microbes that are on the different animals, including the octopus, of course. And what you're seeing here is another major piece of the puzzle. We want to know what microbes live in the mud. Wow, that outside layer is sticky. Wow.
So what would that indicate to you?
The stickiness of the outside layer of sediment. What do you think that is?
Acidity maybe? Yeah.
What does that tell us?
More clay. With more clay,
More
yes,
clay.
it's
Does that mean that tell you something about the paleo environment or?
No. I have to see the animals inside the organisms to say something about the paleo environment. But if you have more clay, it can be also alteration, it could be alteration. Yeah. Or more
instead of pelagic, we can have more pelagic, like more the trial.
Yeah.
In
From
the
land and
environment.
from the.
Could be from
Yeah.
land, yeah, or from
Yeah.
from the environment. There's some eruptions nearby.
Yeah.
in the meantime,
For-
there was movement until
For those of you listening in at home, that was expert commentary by our paleo sedimentologist from the University of Costa Rica.
Would you
Yeah.
want to
Yeah.
just repeat what was said there?
Yeah, yeah. You want to take
Yes.
over? Yeah. Okay, and this would be a great time for me to switch and. Thank you. And I am gonna go ahead and give up the narrator seat, and you will have Professor Maria Sandoval with you. She's a paleoceanographer from the University of Costa Rica, and she'll take over the narration. And hopefully give us some really cool sediment stories, the history of the area through the sediments, which is her specialty, over the next hour or so. So, Maria, take it away.
Hello everyone, this is Maria Sandoval from University of Costa Rica. I'm from the Geological School, Central American Geological School. So I will be with you for this hour. If you have any geological question, I will be very happy to answer those questions. Hola a todos y a todas. Habla María Sandoval de la Universidad de Costa Rica, de la Escuela Centroamericana de Geología. Estaré con ustedes esta hora. Si tienen alguna pregunta geológica, pueden realizármela por medio del chat y les estaré comentando un poco con muchísimo gusto. Entonces seguimos, seguimos tomando lo que son, recuperando estos núcleos que vemos acá. Y bueno, como les comentaba el compañero Gustavo Ramírez, que es microbiólogo, en estos sedimentos, bueno, tenemos 3 capas marcadas, o 3, ahí lo van a poder observar cuando salga este. Tenemos una capa generalmente más blanquecina y esto lo que hemos observado es que tiene muchísimos organismos, microorganismos pequeños llamados cocolitofóridos, que es parte del fitoplancton calcáreo más importante en los océanos. Y este tipo de muestras o de rocas, estos son sedimentos en sí, ya casi formándose a roca, son muy finas y tienen bastante arcilla. También tienen un componente calcáreo importante, en este caso, como les dije, cocolitos, o tienen también foraminíferos planctónicos. Todo esto es lo que forma, esta capa blanca, digamos, está formada por organismos de lo que llamamos nieve marina o lluvia pelágica, que viven principalmente esos organismos, es de microzooplancton, que vive flotando en el agua y que viaja en el mar y van muriendo, ¿verdad? Estos organismos tienen un esqueleto, ya sea calcáreo en este caso, y al morir se acumulan en la parte abisal, como estamos viendo acá. También a veces vamos a tener influencia un poquito más de detritos, de arcillas, de tipo más continental o por ejemplo, de procedencia volcánica. En este caso puede ser algunos minerales asociados a algunas erupciones volcánicas submarinas también. Entonces es lo que hemos podido observar acá. To let you know what we have seen right now from these sediments, all these whitish sediments, we call it calcareous ooze. Then it's we can say it's a calcareous siliceous ooze that is formed principally or consists principally of calcareous nanofossils that are part of the phytoplankton that live in the oceans. So when they die, they accumulate their tests into the oceans, and they are accumulating, so they are deposited in the depths. So that is principally that we have here in the bottom, at the bottom of the beach course. And in the upper part of the push core, we have a little bit more, I will say, more minerals. Probably those minerals could be from some volcanic eruptions close by. Could be also alteration or detrital from organic matter too. So sometimes we have also this brownish color is due to iron oxides. That is what we have been looking at the microscope for now, doing some smear slides of those sediments. Bueno, este aparato que vemos acá es el que le llamamos el Excalibur. Ese es el que mide la profundidad en la que estamos. Generalmente, como vieron ustedes, se introduce, ¿verdad? Cada marca amarilla tiene 10 centímetros para marcar la profundidad. Ahí sacamos estos núcleos de sedimento, estos testigos. Aproximadamente miden unos 30 centímetros el tubo y la cantidad que queda en el sedimento o la cantidad de sedimento que podemos recoger con ellos es de 20 a 25 centímetros. Vean esa ola ahí, cómo se ve ese montón de lluvia marina o de lluvia pelágica, como le decimos. Así es como veríamos generalmente la lluvia pelágica cuando es muy abundante. Entonces imagínense que esos son miles hasta millones de microorganismos. Cada una de esas partículas es un organismo, uno de estos pequeños organismos que vemos bajo el microscopio. So imagine that this cloud that we have seen there, when they take out the Excalibur, is full of tiny organisms. Each particle is an organism that was accumulated in the sediment during thousands of years, or it could be even million years that we have. Usually the sedimentation rate in the ocean is very low. So you can accumulate sometimes 5,000 years, in 1 centimeter. Or it could be also, it depends of the productivity in the ocean, but it's usually in those depths is very low. Por ejemplo, lo que son las tasas de sedimentación en el océano en estas profundidades es muy baja. Pueden variar 3,000 a 5,000 años en un centímetro pueden tener de 3,000 a 5,000 años de sedimentación o inclusive menos. Eso va a depender, puede haber más también, pero eso va a depender de la tasa de sedimentación y la profundidad que tenemos arriba en el océano, en la parte somera. Y la producción de todos estos organismos, su reproducción y posteriormente su acumulación en el océano.
After we get to waypoint
Yes.
After that, are we gonna be coming back? Or?
I don't know. I think we will collect organisms there. We will see. Yeah. Do you have to collect this grading style thing, right?
Yeah.
Do you know which ones? Or do we have a which breeder? Or there is no specific one.
Christmas, right? We came over here looking for the only target is
And that?
and then picking up the sonar, looking for hard targets. I think just start working.
Okay. Okay, in general.
I'm not sure all that, but
Okay.
what's going on in my brain.
So we already have the listings, the push course also. Okay. Do you want more hit flow measurements there?
Yeah, well, we go.
When we arrive to the waypoint too? Okay. Okay. Bueno, aquí estamos viajando hacia el punto 2 y vamos a ir viendo y colectando algunos organismos que requieren el estudio, como por ejemplo son las ofiuroideas, como esta que tenemos aquí al frente. Esta es una ofiuroidea, le llaman estrellas quebradizas y se van a requerir para estudios posteriores, por lo tanto, en algún momento pararemos a colectar algunas. Okay.
Way to know if you're being too low without having to stare at your altitude. That's how I can feel what I'm doing. So, okay, just let you know this at all. Let yourself know. Never trust maybe the trust path. Kind of need to point to where yourself is. If you're on a steep hill,
To stop by here to take some of those brittle stars, but I'm asking the chiefs. Okay. Yeah, no. So, yeah, we can go, but just to let you know. Bueno, por aquí vemos un erizo de mar. Hacia lo lejos, ahorita lo podemos... Ah, no. What is this? I thought it was a arching. No, es un... No. Yeah. We can keep going. Yeah. Don't worry. He was fast. Here we are continuing to transit to our waypoint 2. So then we will try to collect some of the brittle stars and to do some studies and also some additional heat flow measurements. Bueno, en la mañana estuvimos visitando las partes más rocosas de este montículo submarino. Vimos principalmente lavas basálticas tipo pilos lavas. This one? This one? Okay. Let me see. Can we close up, please? Is it this one?
So no, so
No.
this is not this, but
No.
I think we do want to collect one of these, like
The brittle.
one of these little things.
Oh, okay, okay.
Like one of those. And you
Perfect.
could just get the whole rock. if you
Okay,
want.
yeah, sure.
I don't know how big the rocks are. It might be easiest.
Yeah,
it might
yeah.
be easiest to
I
just
think
collect
they
the
are
whole
not
thing.
so big. Yeah, we can try to collect
And then-
like this one, maybe.
Yeah.
Yeah. Or this one is another
Yeah.
one.
any
Yeah.
Of these little.
What is this? It's not one of those. Okay.
None of these here.
Okay.
So far.
No.
And then what else was on the list?
And what is? I have some like brittle star here, but
Yeah,
I'm not
so
sure.
I think we were just saying like any little star on this set. So,
Okay, we can
so, like, you
take
could take
here.
like
Or-
that one.
Or
yeah.
that one.
Yeah.
Okay. So we'll try
Try
to
to
collect
avoid
this
the
too.
pink ones because we have a couple pink ones.
Okay. So the
like,
white
the,
ones.
The white or cream.
Cream.
Brown. Whatever
Okay.
color they are. But yeah, if you're right here collecting, you could easily grab
Yeah.
that one. Yeah, that'd be great.
Okay.
Point again, $120. What's your wish list one?
Huh?
Which one's on the wish list?
So that brittle star in the middle.
This one.
That one, yeah. And then one of the little white corals on the rocks. So like the one to the
This one.
exactly.
Yeah.
One to the bottom.
To the bottom,
left,
the right bottom. Yeah, at the corner.
Yeah. Thank you.
Thank you.
Yeah.
Go ahead. Set it down there. Yeah, set it down.
Okay. I'm in the little. You want me to hang around or?
Before we collected the coral, we can do a close up. Yeah. Aquí vamos a estar unos momentitos colectando esos especímenes de corales negros, que ven algunas como ramitas blancas encima de las rocas, esos son corales negros. Tenemos una especialista acá de corales negros de la Universidad de Costa Rica, Valis Cabridi, y ella pues está trabajando con lo que son los corales negros de este sector y tanto taxonómicamente como desde la parte de genética, en colaboración con una de nuestras colegas, Catalina Murillo, del CIEMIC. Yeah. Yeah, this. Yes, please. Here we are trying to collect. Can we do more close up or no? Yeah. No. Okay. It's okay.
When I pick it up, since we're getting the rock, I can bring it closer to the camera.
Okay. Cool. Esta la jefa. Yeah. This one. Ah. Yo dije black. Sorry. No, perdón, black coral. Yes. Okay. Can we take this one or? What?
Yeah, that's one.
Oh, yeah, is that one? Okay. Okay, yes. Sorry, I was saying, oh, black coral is octocoral. Ay, sí, son octocorales, dije antes corales negros, creo en español, no sé. Son octocorales, la especialista Odalisca es especialista en octocorales. Pero hay una investigadora a bordo, estudiante de maestría, que trabaja que... I really? Oh, okay, we can take here. Cool. Which one? This one? No. This? Oh. Okay. Okay, I will. Okay.
I think it was.
I will call him.
Kevin, y'all gonna want this going to a quiver first?
Quiver, Maria?
Yes, quiver. Three or...
So we have something in two?
Yeah, in 1 and 2. You have 1 and 2.
Looks like three's open, so we can hold that one. Just coming out. That's why I say ish. That'll work. Now go ahead and come back out of the camera and walk me to
Is it that we were talking? Yeah. No, the rock with the coral.
No, because the coral is not attached to the rock.
Yes, it is.
So it's a
Yes, it is.
It's a biological sample with a rock.
Which is first, the bio
That's
or
the
the
rock.
with the rock?
Yeah, we see if the rock is.
I mean, usually we put the rock first. I'm sorry, Bob.
Wait, what is it? It's a biologist.
Yes.
Yeah.
We're just trying to confuse you as much as possible. Oh, God.
There's a term, the rock will be a subsample of biology.
Oops, I think this rock is huge.
Will that fit in the quiver?
Yeah. No, no. Do you prefer to cut it? Or? Yes. Yeah, yeah.
Or just snip the car
Yeah,
off the base?
it would be.
Which one would you rather have?
Or cut the.
Would you like a little bit
Yeah,
more?
we
If you
can.
could cut the rock.
Yeah, can cut.
Cut the rock is better.
Cut the rock?
But you cannot cut the rock. You cannot cut the rock like
Do you have a
that.
laser on there?
No.
Gerald seems to think you can cut the rock.
I mean, with a scissor. Yeah, good. Wow.
Wow.
That
was awesome.
Great.
I will cut the rock.
Yeah. In like, yeah.
Let's bring it core quiver 3.
Okay, core quiver 3.
I was just looking for the little secret again.
Yes. We'll collect after the brittle star, and then we will check for the for this little animal.
You want to get a zoom in of it right there before I drop it, or you?
Do you want to close up there before they? Okay. Bueno, estos acercamientos que hacemos es para solicitados por la especialista de octocorales para poder hacer una mejor identificación cuando están en el agua, ya que cuando ellos ascienden a la superficie generalmente cambian un poco de forma, inclusive de tamaño. Entonces, pues aquí están en su hábitat natural, así que se necesita bien unas buenas fotos para tener el... uy.
Do you only want the small rock?
Yeah, the small, yeah,
The small
no,
rock
it's okay.
falls?
Yeah, the
Do you
small
want
one.
me to not let the big rock go?
Yeah, it's okay.
I just don't want the big rock to go in and smash.
Exactly.
So,
Yeah, just the small one, please.
No, if the coral goes first.
Yeah, the coral
rock
will
is
go first.
going out.
Exactly.
Yeah, it's fine. It's fine.
No, but sometimes they can
It's fine,
push.
it's fine, it's done, it's done, it's done.
if there was an option.
Okay, so we'll see if the octocoral survives.
Where are we putting the road star in the equipment?
And then, yeah, then we go to, yes, the,
For the road star?
Sí. Ve, espérese, no se vaya. Que creemos que tenemos a que necesitamos que identifique. The brittle. Yes, there is in the list. I don't know. There is in the list. It's not me. It's not me.
No, these ones are like.
They want a little brittle star from that part.
This one over here, right?
Mm.
That was the one that y'all were looking at
Yes.
when we were landing out.
Yes.
You want me to move this rock so you can get an image of it in place, or?
I think we just yonk it out.
Yeah,
And we'll get an image of it.
Okay, so you're good with,
Just like move this.
Can you check?
And then we'll get an image of it.
you want me to go with this photo? Yeah, that, y'all got the photo?
Yeah, that's.
Yeah. Maybe we have this one.
It's good.
Bueno, aquí estamos colectando una ofiuroidea o las conocidas estrellas quebradizas. Son muy comunes en este tipo de ambientes de fondo oceánico. ¿Qué es eso? Uy, ese es un gusano. ¿Lo vieron? Qué lindo. Ok, nice. Pues estos son organismos, son un tipo de equinodermos, contienen una simetría pentámera. Esto quiere decir que tienen 5 lados, 5 brazos. Quiver 4, yeah. Quiver 4 now? Yeah, Quiver 4. Okay. Yes, it was. An arm was broken. No. Yes. Yeah. Yeah. We lose one. Yeah. But it's okay. Yeah.
Are we saying for anything else right here?
Yes.
We thought we saw,
Yeah, she is
I
sweat.
mean, I feel like I saw one, but
I think
we
it was
have to
a
look around.
sponge.
Yeah, somewhere right in front of us. It was when we were sat down, so it's like right around here somewhere. Definitely.
Sea cucumber. Can I take this?
Yeah, sure.
That big one? This guy? Oh, like a little
Yeah,
bit
this
bigger?
guy. Yeah.
He's down at the bottom, covered in sediment. You can see the legs.
Don't they?
I know. I think it was off to the left, but I don't know.
Yeah.
I think
I
we're
think it
gonna
was
have to like look.
closer, maybe.
Maybe closer. I swear I saw one.
Aquí estamos en búsqueda de un pepino de mar específico que se quiere colectar para el Museo de Zoología e Investigaciones Posteriores. Y creímos que lo vimos, pero no estamos seguros, así que estamos un poco buscándolo.
Look there.
Where?
Is that it? Is that one?
That
Leg
or
thing.
this?
No, to the right. Right.
Like
The
here?
little leggies.
What, this?
Yeah.
Wow,
Is it?
good eye. I don't know.
Looks like it.
It looks like, yeah. Wow.
Oh my god, look how little.
Wow, you have a good, wow. Is it? See?
Looks like.
Looks like, okay.
You wanna
Okay.
get the images of it?
Yeah, pictures?
Yes, please.
You got your images?
Yes.
You want close up?
Yes. Yes, please. Oh.
That's as close as you go.
Wow, it was really dirty.
Mm-hmm. Mm-hmm.
How big is it, Julia?
Very small.
Oh yeah, we got the lasers on to see how big it is. It might.
Can we have the lasers on, please?
They're on, just not. Yeah, it's really weird that it's so covered.
Oh my god, no, this is like.
Oh, it's super small. Yeah.
It's up to you, but I will be this one just because it's like.
Do you want?
It's like
Do you want this one? Sergio?
Maybe can you just poke it? Just to see. I mean, maybe it's larger, but.
Mm. Yeah. Yeah, it's true. So here we are trying to see if it's a sea cucumber that we require for some studies. So we are looking for an genus called Scotoplanes. So it looks like it's one of those, but we are not sure. Please.
Oh, maybe it's dead.
Yeah, that's like the.
But you say that you.
Yeah.
It's weirdly dirty.
He's playing that.
You know, we can take it. You know, looks like it's dead, but.
I mean, is that in the fence or when it's too
Oh, no,
small?
but it definitely looked like it curled up its 2 feet.
It was moving the 2 feet
It
earlier.
was. They were out before. They were straight, now they're curled.
Yeah.
What do you think?
That's good. Yeah.
Yeah. Okay. Just in case if we see another one, we will
Yeah,
collect.
they're usually bigger.
Yeah.
Exactly.
Okay. Bueno, aquí este acercamiento que tenemos, aprovecho para contarles, este es parece ser un pepino de mar que estamos tratando de obtener para ciertos estudios y del género Scotoplanes. No estamos muy seguros, ya que está cubierto de sedimento, y el tamaño no se ajusta bien, pero igual lo tomaremos sí es, por lo menos sí es un pepino, pero bueno, ya veremos si no tomaremos uno más adelante. No, yes. Okay. Cool, thank you. Oh, yes. Yes.
We're going to restart the stream.
Okay. Okay. Go ahead.
Yeah, the APs, si los ven, pero si tienen razón, dead or alive.
Okay, for those who are watching, just let you know, we are going to restart the stream and we will be back shortly with part 2.
That wasn't it right there? That one more that we saw right over